Hello all, welcome to CCSK V5, the ultimate exam cram, and I promise you this one video is enough for you to clear the CCSK exam. Before we get into CCSK V5 exam cram, let's take a step back and try to understand why we need to become a Cloud Security Alliance's CCSK V5 certified. It has a global recognition. More than 120,000 professionals all around the world have become CCSK certified. It has future-proof skills. It not only explains you about cloud computing, but it also talks about AI and other technologies that leverage cloud computing. And it also provides you an enhanced credibility to the client, to the customer, to your organization that you know cloud very well. And it also provides you a very comprehensive knowledge about cloud security, and it is one of the industrial leaders. We don't have many vendors who actually provide you credible, most acknowledged cloud security certification just like this one. So these are the very important reasons why you have to become a CSA CCSK certified. So to talk more about the exam, first we will understand the exam format. So it has like 60 multiple choice questions, and most of these questions will be like multiple choice. So you need not select even multi-select. It will be only multiple choice questions. And then the exam time is 120 minutes, which is 2 hours, which is more than enough. So you read a question, you'll have a chat bot which can actually where you can search about the relevant topic, and it will guide you where you can find detailed information about it, and you can go to that book, read about that topic, try to understand the question, and then you can identify the answer from that, and you can come back and answer. Okay, and out of which the passing score is 80%, so which means out of 60 questions you have to score more than 48 to make sure that you clear CCSK. And it is an open book test, as I mentioned. Like there is also a chat bot option available, so once you find any question, if you don't know any specific topic, you can search it in the chat bot, and it will give you an information on where you can find more details about that particular topic. So go to that corresponding material, read that read about that topic, and now you'll get an idea to answer the question, and you can come back and answer the question. The best thing about that is it is not just open book, it also provides you two attempts to clear the exam. So once you procure the voucher, you have like 2 years of time, and within that you can take the exam two times. And I promise you, if you go through this video end to end with, if you're taking all the notes, I'm pretty sure you'll be clearing it in the very first attempt. But unfortunately, so far the pass rate is very low, on the lower side, right? So for an exam which is open book, for an exam which provides you two exam attempts, the pass rate is only 62%. So that's why you cannot take it for granted. So make sure you go through the entire video, make notes, revise them, and then get into the exam so that you can clear it in the very first attempt. And this is the domain wise breakdown. So of all the 60 questions, how many questions will come from each of these domains? So I'll leave it up to you to go through it. The one point which I want to cover here is how we need to understand how these topics are interconnected. Right. So when we talk about Cloud Security Alliance, CCSK, and other management related certifications, it is very important to connect those dots. Right. So let's say you want to be a cloud security engineer, right? The very fundamental thing that you want to know is you need to understand how cloud operates. So that's where the cloud computing concepts and architectures are very important to empower you to become a well-known cloud security, well-informed cloud security engineer. Once you are like now proficient with cloud, now you want to recommend your organization to leverage cloud computing in a more secure manner, right? So part of that is to go and get the stakeholder buy-in, right? For that stakeholder buy-in to happen, you need to know about the cloud governance. So there'll be a governance board with whom you have to convince them to take up this additional responsibility, or like form a separate team for cloud governance, right? Great, now you know cloud, the management has approved to leverage cloud. That doesn't mean we can directly come and deploy the cloud, right? So before deploying it, we need to understand the risks that are getting introduced by leveraging the cloud computing. It's one of the very important concept. So your management can approve it, but with only that you will not be able to go and deploy. So you need to understand what is the new risk that is coming up, right? So now the infrastructure will be managed by a third party. uh, or you see your organization aligned or aligned to a compliance which actually demands you to own the infrastructures. We need to understand about the risk, the audit, and the compliance perspective of it. Right. Enough of that. So those are at tabletop discussions that are happening. Right now, you know about cloud. You do the you have like management buy-in, and you have a cloud governance team, and you have also analyzed the risks, and you are responding to those risks, right? You will be like mitigating them or you'll be accepting them, but you are responding to that. You manage that risk, right? After that, now the part comes where we will be building, your cloud related services, right? The very first thing is you need to design how the organization is getting managed, right? So some, if it is an application, some of them may segregate it based on the environments like dev, test, prod, or some of them may classify it based on the job functions. Like HR will have their own like organization, finance team will have their own organization, your development team will have. So we need to design how the cloud services must be applied to your organization. So that will be covered in domain for organization management, and part of that is to onboard those users and provide them access to create services, right? Give them the appropriate level of permissions. So that comes under identity and access management. Once it is done, we'll check whether everything is properly getting monitored. So whomsoever is trying to log in, it is getting whether it is getting logged, right? And if they perform any action, whether they are getting logged. So that will come under security monitoring, right? And then not just monitoring alone, so we will look at the infrastructure level security, right? If you're going for an VM or an EC2, right? So how are we going to secure that? So infrastructure level security, and how we can restrict only authorized users to access your applications. And then we also will discuss about cloud workload security, which is like application level, right? So if you're going to deploy a container, or if you're going to deploy an app service, how are we going to manage that, right? So that comes under cloud workload security. And what about the data, right? That is a popular saying which says like security follows the data, right? So we need to understand how the data flows within the organization and whether we have appropriate controls at all the different levels. So that comes under data security. And we'll also talk more about application security. And we have secured everything at a design stage, at a development stage. We have implemented all the appropriate security controls. But beyond that, when it is go live, when it is in the production phase, definitely there may be some incidents happening, right? There may be an employee's password which may have been leaked due to, let's say, like social engineering, right? Or there'll be like a security misconfiguration that had happened, which may result in providing access to all the secrets in the key vault, right? There may be some incidents happening, so we will need to have a very strong, robust incident response procedures. And we also need to look about the resilience options also. Resilience as in like, if my this is not due to any attacks but due to a disaster, right? I have to shut down my entire like infrastructure. How can I operate it from another region, or how can I access my data from a different region altogether? So that comes under resilience. And we'll also talk about the related technologies, so how cloud is impacting the emerging technologies like AI, blockchain, quantum computing, and how those technologies are impacting the cloud. So we'll discuss on both those factors. So this is how we need to connect all these domains, right? You will learn cloud. By learning cloud, you will go to the governance team and you will get their buy-in, which is like cloud governance. Once you get their buy-in, you will do the risk assessment. So you need to understand what are all the risks that are introduced by bringing cloud, and what are all the audit, and how the audit and complaints will respond to. So these are at the tabletop level. Now at an organization level, how should we actually classify them, right? And what is the identity and access management? Once we classified, we are bringing in users, so how are we going to manage the identity and access management? How are we going to monitor them when the users are logging in? What are all the things that we need to log? So that comes under security monitoring. And then once those resources started creating VMs or app service or containers or database, right? What are all the security that we need to have? We will cover it in the infrastructure security, uh, application security, data security, workload security. After having all these security options, still there may be some incidents that is happening. So we'll have like a security operations team with a very strong like incident response process. So we will pick those incidents and we will respond to them individually. And we will also understand how cloud is impacting emerging technologies, and how emerging technologies are impacting cloud. And before we get into the exam cram, here is a small introduction about me. So I am Shiva. I have like 13 years of experience in IT, and I'm like CASSP, CCSP, CCSK, CISA, and TOGAF certified professional. I'm an ISC2 authorized instructor. I'm also an Udemy instructor, and then I'm also a popular top mid counselor. I have been a Microsoft certified trainer for past 5 years. I have been working in cloud security domain for more than 5 years now, and I have cleared CCSK in like V5 with like 5 days of preparation. And I have trained more than like 10,000 professionals all across the world, and have helped thousands of them to get certified in cloud, in TOGAF, with ISACA and ISC2 certifications. And I'm also like well known for posting daily cloud security questions in LinkedIn. So if you haven't seen that, go and check that. I have been like consistently posting all the cloud security related questions, and it would be very useful for your preparations. All right. As we discussed, the first domain is cloud computing concepts and architectures. So before someone starts their cloud journey, it is very important for them to understand how cloud operates. Before they go and advise their organization to take cloud, it is very important for them to be proficient with cloud. And to impart that knowledge, we have the first domain where we discuss about cloud computing concepts and architectures. And for all these domains, one of the interesting thing that we do is the first thing that we are going to see is how it is different from on-premise. Right? In cloud computing, it is not some new technology that we are going to discuss or see. Right? It's not like OpenAI's Chat GPT or LLM, right? Where we are going to see something altogether new. But we already have something is already running, some application, some website is already running, but it is running in an on-prem. It is running in an outdated technology. Now we are moving to cloud, right? We are discussing about how it operates in cloud. So it is very important for us to understand how it operated in on-prem and what is different in cloud. If we get that understanding, then all these domains will be very easy to follow. So how cloud operated, how cloud is different from on-prem from an operational point of view, right? In an on-prem, there will be servers which will be owned by the organization, right? And they know exactly where their servers are located, right? And for the organization to run the server, right, they always need a technical person, right? So there'll be like two options here. One is buy or build. For a buy, organization will purchase hard disks, organization will purchase RAM, organization will purchase procure all those network cables, and then they'll give it to the IT team. They will assemble those servers, and then they will deploy the operating system. They will configure the credentials and provision it to the user, right? That is how it operates in on-prem. But when we talk about cloud, there are like two underlying technologies or terminologies which clearly specifies the difference between your cloud and on-prem. The first terminology here is virtualization, which is abstraction, right? We talked about the organization knowing where exactly their servers are located. In a cloud, that is not possible, right? Because we are introducing a new party called cloud service provider who will own those underlying infrastructure, right? They will own that underlying infrastructure, and they are responsible for maintaining it. So because of that, we as a cloud service customer will no longer know where our server is exactly located. We may know a specific region. We may know that availability zone, whether it can be US East or it can be South India, right? We may know that region, but we may not know within that region, within which data center, within which rack that server is located. So that location is abstracted from us or hidden from us, and that is done with the help of a technology called virtualization. So virtualization emphasizes on sharing that underlying infrastructure with different customers, right? In an on-prem, organization will own the infrastructure, and organization will deploy their applications within their on-premises. But in cloud, it is a pool of infrastructure which will be shared across multiple customers. That sharing is basically done with the help of this virtualization concept, and in cloud, it is specifically done with the help of a software called hypervisor. So you'll have a hardware infrastructure. On top of hardware, you will install a hypervisor. Using that hypervisor, now the underlying infrastructure will be shared across multiple customers. So this is called um, Virtualization, this is called hypervisor, and this is called virtualization. If you're still not familiar with hypervisor or virtualization, probably in your college days you may have used a software called VMware Workstation, right? If you want to install a Linux OS, right, that is an example of a hypervisor, right? So by installing that, Linux OS on your Windows machine, you are hiding that underlying Windows OS is there, and you are allowing the Linux OS to directly interact with the hardware. So that is an example of virtualization. So is virtualization alone a cloud computing? Will we call VMware as a cloud computer? Definitely not, right? Because cloud computing gets completed when you integrate your virtualization with the orchestration. So the second thing is orchestration, where it talks about automation. Remember the buy or build that we discussed, right? Where organization either they will procure the RAM chip, ROM chip, or they will directly purchase a server from a third party and they'll deploy it. But for both these concepts, we need to have a technical person available. That technical person will do all the configurations for you, right? But in cloud computing, that is no longer needed, right? We introduce something called orchestration, which is an automation of the workflows, right? I go to my AWS console, or I go to my Azure portal. I select all the configurations in my VM, and at the end, I'm just clicking a create button, and once I click create, all the workflows in the backend are getting triggered, and it will be automatically create a server for me and provision it to me. And that is done with the help of this orchestration concept. And in cloud, in real time, it is done with the help of your REST APIs. So you no longer require a technical person. You no longer need to manage that underlying infrastructure. So these are the two key differences that you need to know when we discuss about cloud computing. Okay, so one is virtualization, which is done with the help of hypervisor. Second is orchestration, which is done with the help of REST APIs. And one of the most beautiful things that the CCSK is doing is it is combining all the different standards that are available related to cloud computing. So it is kind of harmonizing or making it uniform, or taking the concepts from all these three different standards, and they are combining it to provide us an unified view. So the three standards are: one is NIST-SP, which is a US related standard for National Institute of Science and Technology. So this standard talks about definition of cloud computing, and it is one of the very popular NIST standard for cloud computing or any cloud standard. And the second one is ISO IEC 22123-1. So this is an international standard. NIST talks about for US related services. This is for international standard. And previously it was 17788 and 17789. Both those standards are retired. So in your exam or for any practice question which refers 17788 or 89, those are retired and they are no longer applicable. The latest standards are 22123-1, which talks about cloud definition and the terminology, and 22123, which talks about cloud computing reference architecture. So CCSK actually combines all these standards and provide us an unified view. So what is available in those standards? So this is the bird's eye view of your NIST SP 800-145. And ISO also talks about all the same concepts. It is just adding one more characteristics, which we will see at the end. So at the middle, if you see, it has like three service models, right? One is called IaaS, PaaS, and SaaS. For any application to be deployed, we will have like four different layers. The bottom layer is infra, and then OS, and on top it will be application, and on top it will be data. Okay. If you as an organization is going to request only infrastructure from cloud service provider, then it is called infrastructure as a service. The basic example is your virtual machines. So it will be very cheap service, and it will be very cheap. It will be, you will organization will have most control, but organization has to manage it, right? Throughout organization has to manage. So that is the balance between owning the server and managing it. Okay. And wherever you have an inbuilt IT team, for a large enterprise, they would already have their own inbuilt IT team. They will generally go for IaaS, right? But if your organization is a startup, or if your organization have only developers, then you cannot expect developers to manage the underlying infrastructure. In those cases, you as an organization can go and request cloud service provider to give you infrastructure and OS also on top of it. So that is called platform as a service. So you are renting not only the infrastructure but the operating system also. So the operating system will be owned and managed by the cloud service provider. You will be taking care of the application and the data that is residing in the application. That type of service is called PaaS. Wherever you have developers, you generally go for PaaS service. And the last is SaaS, where you are saying like, instead of you build the application, you are procuring an already built application, just like commercial off the shelf softwares, right? So that is called software as a service. For example, your Google suite, workspace suite, or your Microsoft Teams app. So you procure a Microsoft Teams software and you are deploying it to the end user directly. That is called software as a service. So software as a service will be more costly, but it has like very less administration overhead for an organization. Organization in SaaS is responsible only for the data and configuring the application, not about developing or installing the application. So that is software as a service. And on bottom you have deployment models. Deployment models, we have like four types. The first one is public. Public is where like the underlying infrastructure is handled by the cloud service provider. So then it is called public server. So you no longer have control over the underlying infrastructure, and the underlying infrastructure is owned by the cloud service provider. Then it is called public cloud. Whatever we are using, right, most of the time it is only public cloud, where the underlying infrastructure is owned by cloud service provider. If you don't want that to happen, or the regulation that you want to adhere to is not allowing you to do, in those cases you can go for a private cloud where the entire infrastructure will be owned by the organization. It is kind of very similar to on-prem, but only thing is it is a virtual on-prem. In an on-prem environment, instead of having a direct access, if you are including your virtualization and orchestration, then it becomes a private cloud. If you're setting up a cloud environment within your on-premise, then it is called private cloud. It is very costly, but it gives you highest security, right? So that is private cloud. We have like very limited uh, private cloud instances available. And then you, instead of restricting it to a single party, if it is a group of organizations that share the same infrastructure, then it is called community. Instead of one organization owning the infrastructure, it will be a group of organizations which will own that underlying infrastructure, then it is called community. In most of the gaming world, you will have like subscriptions, cloud subscriptions, those will come under community cloud. So in private cloud, the infrastructure will be owned by one organization. In community, it will be owned by a group of organizations, not open to public, not accessible to everyone in public, but it is owned by a group of organizations, a group of parties. Then it is community cloud. In a public cloud, the entire infrastructure will be owned by a third party called cloud service provider. So that is public cloud. The last one is a combination, right? It can be a combination of a private and public, can be a combination of community and public. It can be a combination of your on-premise and public as well. So that is called hybrid cloud, because certain regulations will actually ask you to own that underlying software, right? Take an example of a banking. There may be like 50 or 100 applications, right? It talks about loans, it talks about all the non relevant or non-critical applications that are available, but it also has your card details, it also has the customer name and the PIA information. If the regulation says that the bank that collects the customer detail must store it in a service which is owned by the bank, right, then they cannot move everything to on-prem, because the cost is not an efficient option. They cannot move everything to public cloud, because in that case we are not adhering to the complaints. To achieve the balance between cost efficiency and uh, compliance, will go for hybrid cloud, where we'll move the sensitive critical data and applications to on-prem, while we have all the non-critical applications non-sensitive to the public cloud, and we will connect between them. So this concept is called hybrid cloud, and hybrid cloud is generally considered as the most flexible deployment model, right? And That is one load balancing between this private cloud and public cloud, which is called cloud bursting. So cloud bursting will happen only with hybrid cloud, where you have an application which is running in a private cloud, right, or on-prem, and if it receives a traffic beyond its handling capacity, beyond its threshold, beyond its handling capacity, then that application can be migrated to its public cloud instance within the organization. Like, it's a hybrid cloud, so they have an instance of public cloud, so they will move the application temporarily, they'll clone the application temporarily to this public cloud, and they will handle that additional traffic alone. And that feature is called cloud bursting, and it is possible only with hybrid cloud. Okay, hope this is clear. The last one in this is the 5 essential characteristics. Only if we have these 5 characteristics, then we will call it as a cloud computing. And those characteristics are generally called BROM model, BRROM, right? So broad network access, you can access the data with any device, right? With heterogeneous devices. You can access it via your office provided asset, you can access it via your personal device, you can access it via your mobile phone, you can access it from anyone's mobile. So that is called broad network access. The data will be centralized. Using any device, you'll be able to connect and fetch the data, right? Compare it to the on-prem, where the data will be stored locally. Only if you log into that particular machine, you'll be able to access the data in on-prem. But in cloud, it is broad network access. So the data will be stored centralized. You can use any device from any location, from any IP address to connect and fetch the data. So that is called broad network access. Second is rapid elasticity, right? In an on-prem, like, you'll have like very limited servers. If you get a traffic beyond your average traffic, then your server will not be able to handle it, will go down, right? But in rapid elasticity in cloud, we have a concept called auto scaling, where you can set a default count, you can set a minimum count, you can set a maximum count. So if my default is like 3 servers, and I can set maximum as 10, and if I receive traffic beyond 3 servers, it can automatically spin off 2 more servers, right? 5 servers will run and it will handle the additional traffic, right? And once the traffic subsides, it can again reduce it, and it will come back to 3 servers. So that is rapid elasticity. Rapid elasticity is an advanced form of scalability. Scalability usually means manual scaling, right? Manual scaling without any dependence on external parameters. But auto scaling is dependent on the user traffic. Based on user traffic, number of servers can be increased or decreased. So that is rapid elasticity. And then we have measured service. In on-prem, whether you use it or not, you have to pay for the service, but in cloud, it is pay per hour bearer. So only if you have like only if you have only if you have appropriate like, only for the hours that you are consuming, you'll be paying it. So that is measured service. And then on-demand self-service. So when you need a server, you can just log into the portal or console and you can create your service, right? You don't need to raise a service no request, get it approved by someone. Those are not required. So that is self-service. I log into the server, I have the permission to create a server, I can just go and create a server. That is self-service. And on-demand, whenever I need, I can just go and create it, right? In an on-prem, you have to wait at least 1 week to get a server provision to you, right? Because it will come from a third party. It has a dependence, human dependency, it has a technology dependency, it has a asset dependency. Everything was there. But in cloud, I can just log into the portal, I can create my own server instance. So that is on-demand self-service. And the last one is resource pooling. Resource pooling it has like 2 definitions. The first definition says the underlying server can be infrastructure can be shared by multiple organizations. So the underlying infrastructure is pooled across multiple organizations. That is resource pooling. Second is, I may run a server today. Once I no longer require, I can return it back, and some other party can consume those same resources again. So that is another definition of resource pooling. Okay, one, underlying infrastructure shared by multiple parties. So that is resource pooling. Second, when one party no longer requires a server, they can return it back to cloud service provider, and that storage will be used by some other person who needs a server storage. RAM will be used by some other person who needs a RAM. So that is resource pooling. Okay, and these are all the five essential characteristics. We generally call it as a BROM model: broad network access, rapid elasticity, resource pooling, on-demand self-service, and measured service. And your ISO definition is also talking about these three service models, four deployment models, and characteristics. Along with that, they have one more characteristic called multi-tenancy. And do you think that multi-tenancy is covered here? Yes, it is covered here. Under resource pooling, we saw two definitions, right? One, sharing, the infrastructure among multiple customers. That is the definition for multi-tenancy. So in NAST, they covered both the concepts in the same terminology, but in ISO, they called it out separately as multi-tenancy. Okay, I hope this is clear with your NAST. And another way of harmonizing is the CSA, they have their own enterprise architecture framework. So when we talk about an enterprise as a whole, it is not just your technological uh, development and deployment alone, right? We need to understand about the business. We need to understand about how it operates in the IT, how it develops in IT, and how it is getting done in the operations. So instead of we going through all these different standards and finding out the best one, CSA has already done that for us. So for business operation, they are recommending SAPSA, and for IT operations, they are recommending ITIL infrastructure, information technology infrastructure library. And for technology solutions, they talk about like going for TOGAF, going for infra service, information service application, presentation services. And for security and risk management, they are again going for open group security forum, which is known as Jericho forum. So instead of we go and analyzing all these different frameworks and find the best one that suits for us, they have already done that integration for us. And you can also Google about CSAEA, so that they will give you a one-page view of all the required components that are needed from for an end-to-end cloud services. I'll give you the link in the description. So when we introduce cloud, right, part of the underlying infrastructure will be owned by a third party, right? So this is adding a little more kind of confusion to the already existing governance structure. So in an on-prem, it is very clear, right? Um, I own all the infrastructure. I am responsible for all the maintenance, and I am responsible for all the misses. It's very clear, right? If you take the on-prem on the leftmost side, it is very clear. Everything is owned by the organization. They will have a clear visibility on what they have, what they don't have, and whatever the consequences they have to face. But when it comes to cloud, we are introducing a third party in between, right? For some things we are responsible, for some things provider is responsible, and that must be clearly understood by the cloud security engineer, right? They need to understand what is organization's responsibility, what is provider's responsibility. They need to ensure organization's responsibilities are carried out, and they also need to get an assurance from provider that their responsibilities are also met. So that is a very important characteristics. And based on the service model, right, we are renting only infrastructure, then infrastructure will be owned by the provider, so they will take care of all the hardware like network device warranted, they will take care of it. If you go for pass, you are asking them to provide the OS also. So in that case, OS will be managed by the provider themselves. Any patch update, they will take care of it. Any zero-day vulnerability on the OS level, they will take care of it. But if something happens at the application level, then it is organization's responsibility in a pass model. In a SaaS, everything is owned by the uh, cloud service provider. Organization is responsible only for the data and configuring those applications. Only those two things organization will be responsible for. And it is very important for us as cloud security engineer to understand this, so that we can serve our customers effectively. All right, with this, we are done with the cloud definitions and concepts. Moving on to the cloud governance. So now I am clear with cloud, right? I understand all these different services, different deployment models, different characteristics required, right? Just because now I know doesn't mean I can just go and enable, right? I need to get a business sponsor. I need to get buy-in from the management. We need to have a separate governance team who can oversee all this, right? And for that, it is very important to take it up to the management on the same. So what are all some of the concerns that your current governance board will have when they when we discuss, when we give them the idea of introducing cloud, right? Already they have the setup, already there's a governance team. When I'm going and presenting them, to introduce cloud in the organization environment or organization digital estate, what are some of the concerns that will be shared, right? So by understanding their concerns, we can very well prepare at our end and we can present it to them, right? One of their main responsible concern is shared responsibility model. We just started left in the previous slide was talking about shared responsibility model, right? In an on-prem it is very clear, right? There is no confusion. Everything is owned by the organization. If it is there, organization knows. If it doesn't have, organization will know. If there are any misses, then organization will take responsibility of that. But when it comes to shared responsibility, it is adding one more layer of confusion, right? Something will be owned by the provider, something will be owned by the organization, right? We assume that our provider will take care of it. Provider says, in the contract it is given to the organization. So all it will lead to additional confusion if you don't have a proper visibility on that. And second important concern that governance board will have is multi-tenancy, right? So imagine two competitors sharing the same infrastructure, right? So multi-tenancy is always considered as a concern when it comes to cloud computing. Though we have like logically isolated them and there are like no tenant access, you cannot access any tenant beyond your capability. Still, most of the customers consider multi-tenancy as a concern, right? So we need to prepare, we need to show them the IT audits or like whatever certifications your provider has to ensure that we are addressing their concerns. And third one is data location. Again, it may look like a separate topic, but it is very relevant, related to whatever we are seeing, right? So it is multi-tenancy, which means the data in cloud is isolated. We will never know where exactly the data is located, right? And with the help of virtually creating the server and managing the data, it becomes there is a very good chance that the data may lead to any like complaints issues. And the third one is rapid evolution of emerging technologies. So currently, all the data in cloud is encrypted. So it's a very basic requirement, right? Whatever data stored in the database or your S3 bucket, anything that you're storing is getting encrypted. It is either by the provider like Azure or AWS, or it is by the organization. But whatever data that is stored in cloud is mandatorily encrypted. Okay. But then there is a latest technology that is coming up called quantum computing. So quantum computing will easily break all the current encryption keys that we have, right? So that is another concern. So I don't have control, and we say like encryption is the uh, security solution for confidentiality or for unauthorized access. But by introducing a new technology called quantum computing, if we can break that encryption, then our data are at risk, right? So it's another concern that the governance board will have, right, when we talk about cloud when compared to on-prem. So to address their concern, we need to have a proper framework which addresses, all these different options. And one such framework that has been recommended by CSA is the framework hierarchy. So this is a framework hierarchy that I have designed it on my own, so it's not in the book in the same way. Okay. So first thing we need to worry about is the risk, right? What are all the new risks that are getting introduced, right? To do a risk analysis, these are some of the standards that you can refer to. You can refer to NAST 800-30, or for an ISO standard, you can go for 27005, which is a very good standard for risk management. You can go to CAS standard of risk management, or you can go for FAIR model. So FAIR is a model to quantify the risks, right? So that you will have a better picture on what are the risks that you need to address. Once you get that risk, right, your current environment, the risks, right? To address each of these risks, you will go for a program framework. You will create a program to address probably a severe risk. Probably all the high level risks must be addressed using this program framework. And to do that program, right, to do the program, you have some trade frameworks like NAST cyber security framework, which is a very popular framework, right? Identify, detect, protect, respond, recover. ISO 27001 information security management standard, or COBIT standard. You can take any of these standards. So you are analyzing the risks that are getting introduced by um, bringing in cloud, and to address each of these risks, you will create a program, right? And the outcome of a program is control, right? You will be deploying some controls, right? Now your data is getting stored in cloud, right? Now you're putting encryption as a control, right? So that is control framework. And for control framework, you can again refer to NAST 853. You can refer to CAS critical security controls and Cloud Security Alliance cloud controls matrix. So you can refer to all these documents to address your concerns related to control. So all these are again interrelated. So governance, they'll have their own concerns. For those concerns, you will be performing a risk assessment. The outcome of risk assessment, you will identify the risks, and to mitigate those risks, you will create programs, right? Multiple programs. The outcome of the program is the controls, right? You will deploy controls, you will monitor those controls, right? For the risk, you can refer to standards like NAST 830 or FAIR or ISO 27005. For program, you can refer to ISO 27001, NAST Cybersecurity Framework or COBIT. And for controls, you can refer to NAST 853 Cloud Security Alliance CCM. So by introducing this, by going through this, you'll be able to address all the governance concerns. So if you see, this is the information security framework, and they would have defined a policy which is applicable both to your cloud as well as your on-prem. And for anything specific to cloud, you can have a separate vertical where you will discuss all the cloud security control objectives. What are all the objectives? Because you no longer have control on the underlying infrastructure. You no longer know where the data is located. You no longer know whether your data is prevented, or whether any new technology is actually breaking the data. So you'll have a separate vertical for cloud security control objectives, and for all the different providers, you'll have their separate controls and procedures. Procedures are detailed instructions on how to implement those controls, right? And it has to be mandatorily followed. So all this must be laid out so that it is very easy for any third person to come and implement the control operations. And part of cloud security framework, there are two ways. One is cloud controls matrix, which we just saw. It is again like available in open source for CSA. Once you download the preparation kit, you will find an Excel sheet which has cloud controls matrix. So it is one of the very important tools, not just for to understand or find the list of controls, but it is also mapped against different compliances, so that it is very easy for you to know. Like if you don't have any European customer data, then you can completely ignore the GDPR related mappings. You need not worry about if a particular control is not having GDPR, right? So you can simply ignore that. So that is cloud controls metrics. The other one is you also have a CSA security trust assurance and risk registry. So there are two ways. One, first level is CSA star certification, where you can do a self-certified. You can say like you are self-certified CSA star, or if you want to make it more robust, more um, if you want to add more value, then you can give it to a third party for audit, and you can get a CSA star attestations. These are two ways by which you can ensure your cloud resources are properly secured. So with that, we will address all those governance concerns. Now we will look into the risk operations, right? So I know, I know the cloud, I presented to my management, they share their concerns. Now I have shared them the risk frameworks and like programs and controls, right? Now after all that, I'll do a final risk assessment, right? I'll do a final risk assessment. I'll check whether my cloud resources are like exposed or vulnerable to any of these risks. So one of the very popular list that they have given here is CSA's pandemic 11. So these are the 11 types of threats which any cloud service may be exposed to. So these are just the risks that are highlighted by CSA. I have mentioned the controls also on how to address those risks. So if you start with, it has like insufficient identity IAM related risks. So the proper way is to have a proper IAM policies having MFA. Second is, it talks about insecure interface and APIs. Why it is important? Because cloud computing is running on the orchestration framework. Orchestration is running via your REST APIs. So if you have an insecure API, then it means all the data may get exposed, right? To prevent that, you need to have secure API development, you need to have authentication, authorization, logging mechanisms, right? You need to have rate limiting, filtering, everything. And another common error is misconfigurations, right? And you can try to automate the configuration management using infrastructure as code. Again, very popular one is to have a lot of cloud security architecture. So we will have like very good enterprise architecture for on-prem, but when it comes to cloud, due to lack of proper technical person, or due to probably time crunch, we may not have a proper security architecture, which may result in data leakage or data exposure, right? So we need to have a very good cloud security strategy which incorporates all the robust security principles like zero trust and design patterns, right? In secure software development, the resources that we consume using that, if we create insecure software, then underlying infrastructure will be exposed, right? To prevent that, you need to do a proper like SAST and DAST security testing, and you need to integrate it within the CI/CD pipeline, so that even before deployment, all these are thoroughly checked and addressed before production. And then you have like unsecured third party resources, so we are depending a lot on the third party, right? So we need to do a proper vendor assessment, and we need to enforce contracts where it allows. See, mostly all these providers, right? One of the very efficient way to check whether they have appropriate controls is to do a third party audit, right? Go to their site and do a third party audit, do an audit, but it is not allowed. Most of the providers will not allow for that right to audit capacity. So we need to have a strong, let's say like contract language, which actually favors the organization instead of provider. And other risk is system vulnerabilities. So do proper patch updates and do vulnerability scanning. Accidental cloud data disclosure, right? The best way to prevent that from happening is to encrypt the data at rest and transit, which is already done, right? Whatever data you're getting uploading to cloud or moving to cloud, it will by default get encrypted. Only question is whether the key will be given by provider or whether the key will be provided by organization, right? And then again, misconfiguration and exploitation of serverless and container workloads. So these are specific. Serverless is specific to cloud computing, and if anything is misconfigured there, then the data will be at risk, right? So we need to have like proper container security tools to handle that. And another one is organized crime, hackers or APTs, advanced persistent threats. So we need to have not just one security, not just preventing the security. You need to have preventing, you need to have detective, you need to have corrective, you need to have all the different types of controls to discover, to identify, to detect, to respond. Okay. So not just one control, having a firewall alone will save our entire infrastructure. That is not going to work. We need to have different levels of control. The last one is cloud storage data exfiltration, where like the data leakage is happening at the cloud storage level. One thing is to encrypt the data, have logging and alerting. If anyone unauthorized person is trying to access, it should log an alert, right? And restrict the public access. So these are the 11 risks that any cloud resources may be exposed to, and these are some of the relevant controls. And this is the cloud risk management framework. So I know like management has given an approval, but I need to perform a risk. I need to identify those risks. Once I identify the risks, now I'll list down all that, and then I'll prioritize which has more value, right? If I'm someone at the like e-commerce level, then an availability risk is more impacting me than the confidentiality risk or integrity risk. So I need to prioritize those risks, and based on those priorities, now I can select any risk treatment option. Generally there are four risk treatment options. One is acceptance, where I'll accept the risk as is. Avoid, I'll avoid that business altogether. Transfer, I'll transfer it to a third party like an insurance or someone. And last one is mitigate. Mitigate is the most common solution, where I'll deploy a control to mitigate those risks. And with the risk management framework, now I'll assess my cloud service, right? I'll try to understand each of these risks and how it will impact me. So I'll know the business request. I'll go through the CSP's documentation. I'll find out any external resource and then map it to the compliance. See, my organization, it deals with credit card details. So I should be PCI DSS compliant, right? Now I'm I'm going to have a contract with a cloud service provider. I need to go through their documentation to understand whether the same PCI DSS control which I should adhere to is being adhered by the cloud service provider also. I'll also look at external sources to make sure there are like if there are any like incidents reported on that, right? And once I find that, I'll map it to my compliance. I'll map it to the data classification, right? So as I mentioned, a card holder detail must be owned by the organization, right? It cannot be given to a cloud service provider, right? So the data classification must be mapped, and we need to find the required and compensating controls. We need to find appropriate controls for a sensitive data. Then I'll do an encryption. So that's the required control. If I don't have an encryption, then I'll probably like go for any compensating controls, right? And I'll approve those data types and registry. I'll add it to the registry. I'll say like for this, I'll give you an example in the next slide where like for a particular service. So if you see it's an object storage service, the data types are public and sensitive, the risk is very low and expiration is annual. If you see there is a PA data in a CRM solution, so the risk is moderate and quarterly. So if it is moderate, then I'll have to review it quarterly to make sure that there are no risks available. Okay, so this is how I have to handle my uh, cloud risks, right? It is not like one size fits all, right? It's not like one control which will protect all our, but we need to understand each of those services and what are all the risks that are exposed to, and what are all the data that it basically handles, and based on that I can give a risk level and I can go for a appropriate review level also. And some of the complaints concerns, or so we talked about governance concerns in the domain 2. Now here we will talk about complaints concerns. Complaints concerns is very simple, like location of the cloud provider, location of the cloud consumer. Right now we don't no longer have the control of that exact hardware, right? So location is the concern, location of the data subject, right? If any three of this, any one out of these three is in European Union customer, then GDPR will be applicable, right? So that's why location is very important, right? If either provider or consumer or like data subject is a part of a Californian citizen, then CCPA will be applicable, right? We need to understand where the location is, location where the data is getting stored. We need to understand legal jurisdiction of the contract, right? Stakeholders and any treaties, right? Which let's say one, there are like two conflicting laws which are very popular. Like GDPR actually says European customers' data must be processed only within European Union. Okay, and then there is another act in US which is called Cloud Act. Cloud Act, right? Cloud Act says um, no matter wherever the resources are stored, right? Wherever the servers are stored, if a US federal government requests, that data must be extracted and given to the US federal government or legal law enforcement agency. So that is a requirement of cloud. European Union GDPR actually says you have to process only within GDPR. You should not send the data outside European Union. So these are two conflicting laws, right? So we need to understand all these nuances to be able to adhere to the relevant law and to protect the data, right? At the end of the day, right, it may be a provider's mistake, the organization or the cloud customer is responsible to face the client, right? Let's say like I have European customer data and I'm taking a cloud service provider's help. I have CSP, I'm taking, I'm storing the data, I'm processing the data at the CSP level, right? But if due to any mistake at the CSP level, if my data is getting exposed, right, it's not a mistake of my organization, but my CSP who is handling my data, there is some problem there, and due to that, my data gets exposed. It is not CSP who is going to face the GDPR, but it is me. The organization is accountable. We are just transferring only the responsibility, right? The accountability will still lie. The risk will still lie only with the organization themselves, customer themselves. So we have to face that um, like whatever regulatory body or judicial body, and we have to face the consequences. Okay, so that is very important to know from a compliance point of view. And some of the relevant laws and regulations, these are the list of laws like GDPR for European customers, CCPA, it's like California consumer protection, COPA is child online privacy protection law. So which means you should, if your customer is a child below the age of 13, then you need to take their parental consent before allowing them to access your services. And then you have LGPD law from Brazil, you have Japanese Act, you have Australian Act, you have GLBA, which talks about PII for the financial services, financial customers, HIPAA for Health Information Act, DORA for digital operational resilience, EU AI Act for all the new AI services. EU AI Act is applicable. Cyber Security Act, right? Cyber Security Law of the People's Republic of China. You have PCIDS, payment card industry. If you are dealing with any card holder data, then it is a very important law for you. And for complaints in the cloud, these are the four important things that you need to keep in mind. One is secure handling, right? Secure handling is data in transit, right? So your data, like there is a streaming service, there is a movie. If you play the movie, it is secure handling. The data must transfer from there to your endpoint device and the data must load. So that's an example of secure handling. Secure storage is where the data is actually stored. Your database, your, whatever data that you're storing in cloud, images in your OneDrive, whatever it is, those are like secure storage. So the data at rest must also be encrypted. Data in transit must also be encrypted. Data at rest will be handled by symmetric encryption. The most popular algorithm is AES 256. Data in transit will be handled by asymmetric encryption, and the most popular thing is TLS 1.3. You will have like a TLS 1.3 to handle the data in transit. And you need to perform a due care. Just because you have a contract, just because you have a contract with a reputed cloud service provider, doesn't mean that we will sit idle and assume that they will work effectively. And the same thing when we discussed about shared responsibility model, right? You are from the organization, you are responsible for, let's say, like application and data. So you take care of that. You take care of the data encryption, you take care of the application security, right? That while the OS and infra will be managed by cloud service provider. So as per the contract, they will manage, they are responsible for OS and infra. You are responsible for application and data. You as a security engineer will take care of application and data. That is fine. But it is our responsibility, your responsibility, to make sure that provider has implemented controls for the OS and infra for which they are responsible, right? That is called due care. We need to do a periodic audit. We need to request information to confirm that they have applied those controls. So that is due care, right? We cannot, just because we have a very good contract that is signed, we cannot sit idle and expect provider to do, things for us, right? It is our responsibility to go look and verify at the provider level also. The last is audit trails. We need to have proper audit, right? At the end of the day, in GDPR, right, if there are any breaches, then the fine is either 20 million euros or 4% of your last year turnover, whichever is higher. But that's the fine, right? But if you can prove that you did your due diligence using this audit trails, if you can prove that you tried all your best, then the fines can be reduced also. Okay, so that is why it is very important to document all this, and for all that you need to have the proper audit trails. And we talked about, complaints concerns. One of the things is to adhere to the standards. So what are all the some of the standards that we can look out for? So one is, you can have ISO 27001. So it is also the control framework that we discussed, right? It talks about all the security controls that is required from an information security point of view. Then you have system and organization controls, which is actually designed by American Institute of Chartered Public Accountants. It's one of the very detailed report that you can get about a provider, right? And SOC 2 report, SOC 1 talks about financial information, right? SOC 2 talks about confidentiality, integrity, availability, security, and privacy. So five trust service principles, right? And that is very important. So whenever, like, same thing, right? You get the management buy-in, and now you did the risk, everything is fine. Now you want to go for a vendor, right? There'll be like hundreds of vendors, cloud service providers available in the market, right? Whom will you select, right? By getting the SOC 2 report, for which again you have to sign an NDA. To get the SOC 2 report, you have to sign a non-disclosure agreement. So you will sign a non-disclosure agreement, get that report, and in that report They will highlight whatever controls are present in the cloud service provider, whatever the controls that are not present. So both that will be there. So by going through that, you will get a better picture on which vendor you can actually go for. To do that vendor vetting, this SOC 2 report will be very useful. And you can also go for the star registry, the one we just saw previously, right? Star certification or star attestation, which will also give a very good knowledge on your cloud service providers standards, security standards. And we need to understand about the provider and customer responsibilities also, right? So as I mentioned, your organization is handling customer data, so you have to comply to PCI DSS. And if you are outsourcing your responsibilities to cloud service provider, then that particular provider must also adhere to the PCI DSS. And if a cloud service provider is already complying to the PCI DSS regulation, and if you are like having a contract with the provider, then that is called compliance inheritance. You can inherit the compliance of the provider for yourself. That is called cloud compliance inheritance, which will help you to adhere to the regulations and standards. Okay, if you can see here, like this is compliant, right? While this is non-compliant, the customer application is not compliant. So customer audit scope. So this is the standard. Your provider is compliant with all this, but if your customer application is this is customer's responsibility. So organization A is compliant or application A is compliant, but application B is not compliant, which means again it is not meeting the PCI DSS regulation, while application A and C are meeting the PCI DSS compliant. So this is how we need to understand how the regulation or compliance works when we actually outsource it to a third party. And some of the artifacts of complaints are like again the logs are the evidences, right? You need to have a proper audit logs, you need to have proper activity reporting, right? 6 months back, who has accessed the key vault and what are all the secrets that they have seen. So we need to have that activities being reported. Activity reporting is when an incident actually happens. If someone uh, suddenly like logs in and authorizing accessing a key vault, then it should be logged as an incident and that must be taken care. Right? And then system configuration details and the change management details. You need to have a proper change management process, right? So all this must be documented, preserved, so that we can show it as an evidence during any like internal or external audits. All right, so with this we did all the tabletop work, right? I person A, you understand all the cloud concepts, the service models, deployment models, essential characteristics. You are proficient with cloud. Now you are talking to the board, you are talking to the governance team, you are understanding their concerns, and you are addressing it via the risk framework, program framework, and controls framework, right? And once you get their approval, now you are doing a risk assessment to find out the risks, to find how the risks like are analyzed, prioritized, and you are taking risk treatment, right? And then you are looking at the compliance perspective, then you are looking at the um, responsibilities, providers responsibility, complaints, inheritance, right? Now all those tabletop works are done. Now you are going to design your own organization, right? Part of that comes with the organization management. So for an organization management, generally for any cloud service, right, for any organization that is leveraging cloud service, they can uh, create an hierarchy, right, based on their organization structure, right? Your organization structure can be mapped to an organization hierarchy model, right? Let's say one of these like companies, right? So it has like three levels. If I give an example of Azure, right, the organization is generally the management group level, right? Management group level. Using that, you'll have groups which is called subscription, right? Subscription, within subscription you will have your resource groups. So this is the three level hierarchy. And why it is very needed? It is very needed to enforce the compliance, right? Let's say I'm saying or the organization is saying, um, for example, the resources must be created. All the resources within the organization must be created within US, right? So if they want to implement it across all the employees, then will set it at the organization level. Then they will take that policy and they'll set it at the organization level, which means all the employees within the organization will follow that rule, must comply to that rule, right? That rule is enforced. So whatever resources they are creating, that should be created within US East. Okay. So at an organization level, if I want to implement, I can set it up at the organization level. But I don't want to set it up at the organization level, but I want to set it up at the, let's say like at the group level, at the second level, like where like I have employees in US and India. US employees, they need to create the resources only in US. Indian employees must create it in India. So instead of applying here, if I apply here, employees in India will also need to create the resource in US East only, which is not required. I want US employees to create the resources in uh, US East, while Indian employees, they want to create it in India only. So in that case, instead of applying the policy at the organization level, I can apply at the group level, saying US employees must create their resources in US East region. So that is, I'm applying the policy at the group level, right? Now if I'm an Indian employee, then I'll not be able, I need not, this rule is not applicable to me, so I can create a resource anywhere. Or unless if it is explicitly mentioned that Indian employees must create only in India, in if unless that rule is not applied, I can create resources anywhere. Okay. And then I'm saying no, it is not applicable for all US East employees, but within US I have two regions, US East and US West. Based on the region, um, people who are near to US East must create in US East. People who are near to US West, they should create their resources in US West. So in that case, I cannot apply to group, right? In that case, I have to apply at the deployment level. I'll just say people at US East must create resources in US East. People at US West must create the resources in US West. If you set it up at the deployment level, then it will force those employees alone to create, to adhere to the policy in general. Okay, so this is how hierarchy can help us, right? Hierarchy will, the governance in general will help you to make all the possibilities uniform, to make all the processes uniform. If I apply a policy, it is applicable to everyone within that organization, right? And this hierarchy will help us to determine whether it has to be uniform across the organization, whether it has to be uniform across the group, or whether it has to be uniform across the deployment. Okay. So that is why organization hierarchy is very important, and it requires a cloud professional and someone who knows the organization well to design this, right? So that this can be done um, seamlessly. And two most common things that they follow during hierarchy are: one, they will define the hierarchy based on the environment, dev environment, test environment, or production environment. Second, they will based on the uh, functions, job functions, right? HR, developer, similar. So these are the two ways by which they will generally create those organization hierarchy models. So what are the some of the organization capabilities within cloud service provider? So one is allowing the customers to design their deployments. So from a cloud service provider perspective, these are some of the power that they are giving to the cloud service customers. So they allow them to design their own deployments. They allow them to create their own policies. All the IAM services are centralized. The security services are centralized. The logging is centralized. So these are some of the capabilities or benefits that an organization is giving to the provider. The provider is giving to the organization to help them create the services that are required for them, right? At the end of the day, customer is accountable. At the end of the day, customer is the one who is going to pay the provider, right? So we want all this to be driven by the customer. To make that happen, certain capabilities are given to the customer from a provider. Capabilities are to design their own deployments, to design their own customer policies, to have a centralized IAM, centralized security service, centralized logging. Okay, so these are capabilities provided by the provider to the customers. And how can I create the hierarchy? Again, this we have just saw that one I can have based on business unit and application based, right? So business unit, like we have a very popular Indian tech giant called TCS. TCS is part of Tata Group, right? So Tata Group can sit on top, under which all the different Tata entities will be a part of, like TCS, Tata Motors, everyone will be one of those business units, sub business units, right? So you'll have data groups at the root level, and from that root there'll be like multiple branches, right? One is at the business, like Tata Motors, one can be TCS, one can be Air India, and so on. The other is to have like environment based, right? Not that green environment, but dev or test or pre-prod production. We can segregate based on the environments. Last is based on the geography, people in US East, people in India, so we can segregate based on the geographies also. So these are all different options. There are like no hard and fast rule that it has to happen in this way, but by having this designed, um, aligning to our business requirements, it is very easy for the organization to manage those underlying resources. Okay. And managing some of the organization level security with provider. So when we introduce cloud, right, though it may look seem as a risk, right, because the provider is now responsible for the underlying infrastructure, right, and we are no longer. It also has another advantage, right? The advantage is now provider can bring their own security tools which can be leveraged by the organization, right? As I mentioned, the encryption, if you cannot like afford an encryption, or if you don't have someone with encryption knowledge, you can, like provider will provide the encryption for you, and you can leverage it and secure your data. So by having introducing cloud service provider, we can have additional level securities also. And one of the additional level securities are to have least privilege, right? So least privilege is having only the appropriate level of permission that is required for you to perform your operation. Appropriate level of permission uh, given to you to perform your option. It's neither you have more permission nor you have less permission. You have only the required permission for you to do the do your task. So that is least privilege. So generally what they say is there is a key vault, right? We were saying key vault where you can store your password, where you can store your application passwords, you can store your private keys, you can store your certificates, right? So all these are stored in a vault called key vault, cloud vault, right? Least privilege says person who is creating the vault should not be able to create the secrets or certificates within the vault. So it should be separated, right? Person who is creating a vault, he'll not be able to create that key or secret within the vault because that is not part of their job roles. Right? That takes to the next one, which is role-based access control. Only based on their roles. So if someone is a key vault owner, they should be able to create the vault. They should be able to delete the vault, but they should not be able to. They can like provision or deprovision the access, but they should not be able to go and create a secret. Right? We should not give all the permission to a single user, but it should be driven only by via their job profiles. So that is role-based access control. The same thing with the databases also, right? So you have like data definition language, you have like data manipulation, right? So someone who is doing data definition, they should not do a data manipulation, and vice versa, right? And third is policy as a tool. So you can have the policy like we mentioned, right? So you have defined hierarchy, and these policies are available or given to you, and there will be like hundreds and hundreds of templates available to you to enforce any policy, right? And those policies you can take and you can apply to the organization. So these are available at the provider level itself, and that provider is giving these organization level security options to the customers. And some of the organization shared services are like your centralized IAM, you have like centralized logging, you have CSP threat detection services. Like most of these cloud service providers, by default, they will give you a DDoS protection. By default, they'll give you a DDoS protection because cloud operates in a multi-tenant environment. If your organization hacker wants to do a DDoS attack on your organization, but by doing that, all the resources that are sharing the cloud infrastructure with you, they will also get impacted, right? So a basic DDoS protection is always enabled at the cloud service provider level, right? And you will have like a centralized cost management, and you can also leverage IAC, which is infrastructure as code. Okay, so these are some of the common organization shared service. So common organization shared services, nothing but a cloud service provider will serve hundreds of customers, right? And they will provide these common services to all those hundreds of customers. To individually, they will provide these services to each of those customers. So that is common organization shared service. And some of the considerations that you need to have when you are going for a hybrid cloud or multi-cloud is for one is IAM. So you need to take care of IAM. So when we talk about hybrid or multi-cloud, right, you have two entities now. You have an on-prem, you have your CSP1, or in a multi-cloud environment, you have like CSP1, CSP2. There are two standalone services which can do the same operation, right? So it will become very difficult if you start leveraging both of them, right? If you're managing the users both at on-prem as well as in public cloud, then passwords may not be at sync, right? Or if you're leveraging, IAM in one service and IAM in another cloud service provider also, then it becomes very difficult for us to manage at both the places. So we need to have a centralized IAM. We need to decide what is more important for us, right? By going for, on-prem, you will restrict all the passwords from being stored in cloud. So it will kind of give you an enhanced security option. But at the same time, if your on-premise down due to any reason, then you will not be able to access, your internet-based cloud services also. So if you store in cloud, credentials or password, not the actual passwords, but the hash of the password may be stored in internet. But even if there are any downtime, at on-prem level, still you can continue accessing with the existing password. Okay, so we need to look at all these options and come up to a conclusion. And then network security, again from a hybrid cloud to organize like cloud service provider to your organization, you can connect it via VPN, right? VPN is a traffic tunnel built over the internet, right? Which has like very decent speed, decent security, decent cost, right? But if your data is very sensitive data, or if your application is very critical application, right? You want like the state of the art security for that, then you have something called direct connect, right? Where just like your internet cables, you will have separate dedicated cables to connect your organization network to the cloud service provider. You can select that. It will give you high security, high speed, and at a very high cost, right? So these are again available with all the common cloud service providers. And the third one, especially when it comes to hybrid cloud, you'll have something called hybrid cloud sprawl, which means like like since the visibility is not restricted to one location or one region alone, it is you can create resources in hybrid as well as in enterprise. There may be instances where people will start leveraging the hybrid cloud. Since hybrid it is exposed to internet, people will try to attack, and people will try to steal the information out. To avoid that, you can use a bastion host. Bastion host is nothing but a jump box. If you know a jump box, it will not directly log into that particular server, but it will be a dummy box, right? People will log in, and from there they will have the private IP, and they will make that internal private IP connection, right? Instead of directly exposing the server to internet, uh, they will remove all the public access to that server, right? And they will create a dummy box called a jump box, which will be exposed to internet. And if a hacker or if someone externally trying to access it, they will be able to access jump box, but they will not get any meaningful information out of it. While valid employees, when they log in, they will log into jump box, and from there they will have proper IP addresses, internal IP addresses to connect to that specific resources. So that's how we can address the hybrid cloud sprawl. And some of the multi-cloud scenarios you need to worry about are like it can be a single provider, right? Where like you have on-prem, you have cloud, right? It can be Azure or AWS or GCP. You have on-prem, you have one cloud service provider. Or in some cases, it can be see on-prem, and then you'll have like cloud. Second example is where like primary secondary, where one CSP will be primary and the same CSP at a different region will be the secondary, right? uh, one So where like one CSP will act as the primary and the same CSP at a different region will act as the secondary. So if there are any like restrictions I mentioned like GDPR, where the European customer data must be processed only within European Union. So the front end can be in US or some other region, while the backend database, it will be within the same cloud service provider. They will have the database alone in the secondary region, where in the European region where the data can be processed. So that is primary and secondary. In primary and secondary, both uh, primary and secondary will be the same cloud service provider, right? But at two different regions. And third is full multi-cloud support, where I can take CSP1 as primary and have CSP2 as secondary, right? Which means even if the entire CSP1 is down due to some reason, they ran out of business, right? Or there is like a massive outage at CSP1, if you have CSP2, it will run, right? All your critical services can be resumed as long as CSP2 is running. So that is how you can leverage the power of multi-cloud. Okay, so we saw three examples: single provider, on-prem primary, any cloud service provider is secondary, and then primary secondary, where primary is CSP1, secondary is also CSP1 at a different region, and then multi-cloud support, full multi-cloud support, where like CSP1 is primary, CSP2 is secondary. Okay, so these are three multi-cloud scenarios, and we need to equate it from an availability perspective also. See, as cloud security professionals, right, whatever you are going through, it's not just the topics that we cover, but you need to see where it is getting mapped to, whether it is helping to enhance confidentiality or integrity or availability. In this case, we are talking about availability, right? Having multiple cloud service providers help us to enhance the availability. And some of the tools for IaaS and PaaS multi-cloud, right? So we need to understand, like, the more services that we consume from cloud, right, the more we are having a dependency on them. So it is always advisable to have only the required level of services from the cloud service provider. Just because cloud service provider have a lot of extensive tools, that doesn't mean that we have to go and opt for them, right? We need to, as an organization, need to go driven only based on the business goals, and we need to go for only the resources or tools that we are uh, actually in need of. Okay, and another way is like the small, if it is a smaller organizations, like they will generally, they don't have sufficient manpower to handle all these security operations or the day-to-day operations. So they will generally do the staffing to the managed service providers, right, where you have like a group of trained people who are well versed in handling those incidents, and they will handle the responsibility for the organization. So this is another way by which we can respond effectively to incidents. Either we can have strong like incident response team, we can invest and prepare them to handle any like ad hoc undesirable events, or you can negotiate, you can give it to a third party who's like, generally we call it as managed service provider. They will handle it on behalf of the organization. So organizations management. So when we introduce those organizations management, like for a SaaS or hybrid, what are all some of the ways by which we can handle the visibility, monitoring, and filtering, right? The three things are: one is federated identity brokers, who will provide the identity and access management, right? When it comes to like SaaS or hybrid, it is again like divided, right? It is again divided between one cloud service provider and on-prem and another cloud service provider, right? In those cases, to manage the identities, we can go for federated identity brokers. And for visibility, there are like one on-prem and three cloud service providers: CSP1, CSP2, CSP3. So we need to have a bird's eye view on all those services, right? There can be any incident that can happen at any of these places, at any of these services, right? So we need to have a bird's eye view on all these services, and just like a drone, right? Just like a drone, on top of it, you need to have visibility on all those infrastructures, and you need to be informed early. The quicker you inform, the better your response time will be, and you will be able to mitigate the incident as soon as possible. To make that happen, generally we leverage a service called CASB. CASB is Cloud Access and Security Broker. They generally act like a drone, right? Uh, they will go to very uh, high, they will be at a very decent height. They'll have visibility on all the underlying uh, underlying like ground or whatever, right? So they'll have visibility on all these underlying services, right? It can be on-prem, it can be any cloud service provider. They will be able to monitor, and based on that they will be able to take a they will take the logs, and based on that they can take an action. Third is API gateways. So everything is now triggered via APIs. So we need to have a proper secure API mechanism, which is again one of the controls for the pandemic level, right? We need a secure API process, which involves authentication, authorization, rate limiting, filtering, right? All those must be in place. So when we have organization management for hybrid and multi-cloud, these are some of the factors that we need to keep in mind. Right, so we talked about federated identity brokers, we talked about authentication, authorization, which all like lead to the identity and access management, right? So once you have the policy set up, once you design how the organization will work, the very first thing that you will do as an organization is to onboard those users. That's like the very basic step, right? You will have like 10 or 15 people who actually need to use the cloud service. You will onboard them to the cloud, right? And onboarding them, provisioning them the access, everything is the responsibility of identity and access management, right? So in identity and access management, how it is different from on-prem and cloud. Here you have a lot of options that you can use multiple clouds. In on-prem it is only on-prem, right? So you'll have like an active directory where you will manage, but in cloud there are like multiple options, right? There are like multiple clouds, multiple services. How are we going to manage that identity, right? And there are like multiple models of services also. We'll discuss about that model, like where it is free form or hybrid. Like there are multiple models. Each application may require a different type of model, right? So which is adding the complexity to the management plane and infrastructures and all. Third one is to have a consolidated management and administration function. So it has to, I need to have one screen where I can go and check all the onboarding, I have provisioning, deprovisioning, roles, licenses, everything, right? It should be one screen, right? Since we talked about centralized IAM, right? So this is centralized IAM. So by having your IAM in cloud, you can have a centralized view, right? You can handle the multiple models. You can serve multiple clouds and multiple services using identity federation. Okay, so we'll see about that in detail. So before that, if I want to give access, what are all the different options I have, right? So like there are 15 users, right? Some of them will be administrators, some of them will be only readers, some of them will be like developers, right? So should I give the same permission to all three of them? Like there are three different roles: owner, developer, reader. Should I give the same permission to all the three people? No, right? Each of them will have their own responsibilities, and based on the responsibilities, you will have well-defined permissions, and you need to apply only those permissions. A reader must have only reader permission, right? They'll be able to view all the resources, but they'll not be able to make any changes, right? A developer will be able to kind of insert or delete the data within the table, but they'll not be able to create a own schema. They'll not be able to, they should not be able to go and delete the logs, right? So that those are the permissions, what all they are allowed to do, what all they are not allowed to do. Rest everything is like they are prohibited from doing. And if you are someone who is a owner, you will be able to create the tables, right? But again, you should not be able to modify the logs, right? So all these are defined by their job functions, and that concept is called RBAC, which is role-based access control. Role-based access control says anyone who is a reader should have access to all the databases, but they should not be able to modify it. They should be able to view all the database, the data in the database tables, but they'll not be able to, they should not be able to modify that. So that is RBAC. Okay. One of the advanced feature of RBAC is basically called ABAC, which is attribute based access control. Attribute based access control says for readers who are logging in from like let's say European Union, they should be able to view the European customer data. Okay, we are adding a attribute called location as a constraint here. Previous RBAC says anyone with reader will be able to view all the data. It's a very generic high level rule, but this is a more specific rule. We are adding within that rule, if only a particular attribute, if it matches a particular attribute, then access will be provided. That is called attribute based access control. So it's more fine-tuned, more granular compared to your RBAC. Okay, and the last one is PBAC, which is policy based access control, uh, which is a combination of both RBAC and ABAC. How it is a combination? As long as I log in with the same device, as long as I'm logging in from the same location, as long as I'm logging in at the same my routine time, right? So I connect to my office asset at 9 a.m. As long as I'm connecting at 9 a.m. or 9:30 a.m., it will be acting as a RBAC, right? it will it will act as a RBAC where it will like allow me to do my operations. But if my location changes, or if my device changes, I'm logging in from a new device, or if I'm logging in at an unusual time at Sunday 3 a.m., if I'm logging into my office asset, in those cases it will tag that attribute as a variance, and that is called signal. It will tag that attribute as a variance, and it will go for additional round of authentication. It will immediately throw an MFA to me, and once I pass the MFA challenge, it will allow access. Otherwise it will block access to me. The very best example is if you want to log in to your Gmail from another device, from your, like let's say your friend's mobile, or from any other mobile, from a new device altogether, then as long as you're logging in from your device, it will not even ask a password. It will directly allow you to authenticate. But the moment you're logging in from another device, new device, even though you entered correct username and password, it will go for another round of authentication. It will say like, press that number appearing on the screen or some. It will do an additional round of authentication. It will confirm that you are the same user that you are claiming to be, and then it will allow access. So this is an example of policy based access control. And we also talked about federated identity federation, right? So that was one of the allowing multiple clouds, access to multiple cloud services. It is done with the help of federation, where again, like, we are introducing a third party called identity provider. Okay, my organization, I own an application, right? I own an mobile application, and users can download the application. Instead of my organization managing the identity and access management for the registered users, right? There are like 100 people who want to register to my application, right? Instead of I am managing all those 100 users, managing as in like today they'll create a username and password, I need to have a password policy. Tomorrow the user's password like is locked, right? Our password must be rotated, right? So now they have to call the help desk, and I need to have help desk to support them change the password. Instead of I'm taking all this headache, I can give it to a third party like your Gmail or your Twitter or LinkedIn, right? So that is called federation, and that third party is called identity provider, right? So best example is like Udemy, right? So I'm logging into Udemy, um, right? The option is login with Gmail or login with like Apple ID, login with Facebook, right? Once I click Gmail, right? Will it take me to Udemy sign in page or to a Gmail sign in page? It will take me to the Gmail sign in page where I'm entering my Gmail username and Gmail password, and Google is actually authenticating my credentials here. Google is authenticating whether I'm a valid user. Once it confirms that I'm a valid user, it will generate a SAML token, right? That's at step 6. It will generate a SAML token, and that SAML token will be sent to Udemy, and now Udemy will allow access to my Udemy profile. Okay, so this is called federation. Instead of Udemy managing my credentials, it is relying on Google, who is the identity provider, right? So I go into Udemy sign in page, step 1, Udemy sign in page, right? Now I'm clicking login with Gmail, right? So that is step 2. So now Gmail sign in page is cloned. That is step 3, right? Now I'm entering Gmail credentials, and Gmail, I'm logging in, and once it has confirmed my identity, it will generate a SAML token which will be consumed by Udemy, and my Udemy accesses Udemy profile is displayed. Okay, so this is an example of federation. And then some of the common standards, right? The one I talked about, SAML token. So the basic federation, it was done by SAML, and just for authentication purpose alone, you can leverage a open source mechanism called OpenID Connect, and for authorization alone, you can leverage something called OAuth. See, we can discuss about this in detail, but it is not the scope of CCSK. As long as you know like what is SAML, OpenID Connect, and what are all their functionalities, that is sufficient. Okay. SAML helps with the federation. OpenID Connect will help you with the authentication, and OAuth will be used for the authorization purposes. And these are the two models that we talked about: hub and spoke model and the free from model, right? Free from model where any user can directly access with any of the services. See, identity provider, it can directly connect to the identity service provider, right? There are like three identity providers, three service providers. There'll be a mesh of connections, right? Any identity provider can like provide the token to any of the service model, but it is flexible, but it is not a efficient option. To avoid that, we have hub and spoke model where there'll be a central broker, right? This is like your CASB, right? So your identity provider, it will interact, right? Instead of directly providing access to the application, it will interact, it will validate the identity provider, and it will provision the access to the service provider. And that is called a hub and spoke model, where you are introducing a hub, right, which will act as the centralized medium where all the connections will pass through, and they will validate both the application, they will validate the user, and they will allow access. So that is called um, hub and spoke model. So when we design authentication for cloud services, we can think of both these options and choose whatever like works best for us. And some of the ways by which you can enhance your authentication is you need to have MFA, right? Though I enter correct username and password, there are very common. I always say like humans are the weakest link, right, in cybersecurity. So which means even though I have state-of-the-art security at all the different layers in on-prem, in cloud, in monitoring, I have state-of-the-art security, but if someone can actually trick your employees with the help of a social engineering attack, or by sending a phishing mail, right, now your employee's password is leaked, and because of that your entire security is collapsed, right? The best example was the Uber attack that happened like 2 or 3 years back, where one of the Uber employees was became a victim of social engineering attack, and because of that social engineering attack, and because of that they were able to steal information from Uber, right? And that is, to avoid all that, to enhance authentication, the best solution is multi-factor authentication. And then you also have something called a time-based OTP and hash challenge-based OTP. Time-based OTP is your authenticator app, right? Nowadays it's not even like passwords that are sent, but a time-based 30-second OTP will be generated. Using that, you will be able to verify your identity, right? So that is time-based OTP. And the other one is out of band, where you are sending via SMS, right? Your primary authentication is your laptop, secondary authentication is your mobile phone, right? SMS or voice call, right? So that is out of band. The last one is passwordless, right? Slowly the identity environment is moving towards passwordless, right? When we talk about authentication, there are three ways. One is something you know, something you have, something you are, right? Something you know is your password, something you have is your mobile, something you are is your biometric. So instead of, and as I mentioned, humans are the weakest link. So they want to avoid users entering the password. They want users to avoid remembering the password. To make that happen, we are generally like trying to eliminate something and we are trying to authenticate them via something you have and something you are with your mobile phone and your fingerprint or biometric. So that is called passwordless. We are slowly introducing that to enhance the security options. So that is passwordless. Okay. Next is entitlement and access management. So like we talked about authentication, right? MFA, time-based OTP, out of the band, passwordless. How can we enhance the access management, the authorization part of it? So that's where like you have like policy-based access control. That's, we call it as conditional access, right? Conditional access supporting the attribute based access control is like the preferred model. So as long as you are logging in from the same device, as long as you're logging in from the same location, as long as you are logging in at your regular day time, it becomes very easy, right? You will not be asked for any MFA. But the moment if any of the things different, You log in from a new device, you are logging in from a different location altogether or at an unusual time, it will be logged as an incident. It will throw an additional verification for you, and based on that, you will be able to verify. So that is the um that is how we can enhance the authorization part of it. And also when we use federation, the organization is responsible for mapping those attributes, the role that we have. Like if it is a developer role, it should be tagged to the developer role at the identity provider level also. So that is the responsibility by which we can ensure that the same level of control or access is given at both at the organization level and at the provider level also. And cloud providers, right, we need to make sure they are enabling a back and ensuring the effective security for the cloud users. So we assume like if we give a read only, it is actually a read only role, but at the end of the day, that mapping of read only means accessing or viewing only must be set by the provider, right? We can set up the policy, we will rely on provider to ensure that it is accurate. Okay. Again, not every user account is the same, is of same privilege, right? Like your account does not have the same value as your administrator's account, right? So they are called privileged users. So it can be database administrators, it can be root users in Linux, it can be super users in Windows, but those are privileged users. And you cannot apply the same security as the normal user to the privileged user because they carry more value, right? Which means if a normal user credential is compromised, then the loss or the impact is very less compared to your privileged user account. If a privileged user account is compromised, then it will result in more impact, more damage to the organization compared to normal user account. So if both the users are of different value, then it does not make any sense to have the same level of controls to a normal user and an privileged user. So we need to have additional controls, and some of the additional controls for a privileged user are: one is like having an automated credential rotation, right? So it will impact the number of like it will help us to rotate the credentials automatically, and also to restrict, we can identify at which time the breach had happened. So second one is to enforce them MFA, which is very important. So they are privileged users, they hold the keys to the kingdom, so it's very important to enforce MFA to all those privileged users. And we need to also have a comprehensive audit and reporting, like uh, we need to do that for the normal user also, but we need to do it in a more comprehensive way, right? We need to do a periodic audits, right? There is one capability called access reviews in Azure, where like if it is a privileged user, every 3 months you can automate that review, wherein you'll ask like they'll check like whether that user has used that particular privileged rule within the last 90 days, right? If they haven't used for the past 90 days, then automatically that role will be removed from that user, right? That's one way by which we are ensuring that only required people have access to the privileged roles and privileged actions. And so now we done with the identity and access management. The next is to have sufficient monitoring that is happening, right? And so monitoring, it is not just monitoring user activity. We need to monitor the management plane. Management plane is a differentiator again between your cloud and on-prem. In on-prem, you don't have any management plane, but in cloud, a management plane will be created by the cloud service provider, and it will be given to the cloud administrators, right? So management plane is very important, and it has to be secured properly. It has to be monitored properly. We need to identify the velocity in which the resources are getting created. We need to understand the distribution and segregation, right? The domain 3 distribution and segregation. We need to monitor for any cloud sprawls, and we need to also look for the allocation of responsibilities. So all that must be monitored efficiently and effectively in a cloud environment. Okay. And some of the cloud logs that can actually help us with these actions are: one is management plane logs. So management plane logs, it will give the critical sources that uh, that will give the importance of protecting those management planes. And then you have service logs like the different services, API gateways. For storage, you'll have like access logs. For network, you'll have like VPC flow logs. For serverless, you'll have activity log. DNS, you'll have query logs. WAF, you'll have like again activity logs. All those service or resource-based logs can also be created. And then you have resource logs where VM, it will generate its own log. Storage account, right? It will say like who have accessed it, right? Object storage files access, snapshots and image logs. And you can also have um, standalone monitoring rules which are dedicatedly used for the logging and monitoring functions, like have CSPM, Cloud Security Posture Management. One of the very good examples, your Defender for Cloud. You can have CASB. You'll have like CNAP, which is like Cloud Native Application Protection. You have SSPM, which is like SaaS Security Posture Management. You have Data Security Posture Management, IAM Analytics. You have Cloud Detection and Response, right? And you also have like SIM solution for this, like Security Incident and Information and Event Management. And you have SOAR solution, which is Security Operations and Automated Response, Security Orchestration and Automated Response. So these are different types of cloud logs that are getting generated using these tools. And once we generate these logs, right? So one of the key security practice is to store the logs separately from the environments in which they are generated, right? That will restrict the user access to those logs also. And that will help us protect from any unauthorized modification or logging. So we need to create it, we need to store the logs in a separate environment altogether with very minimum access, right? Only read only access. And those logs will be then aggregated, right? This is for one particular resource. It can be an IAM related resource, it can be a key vault related resource, it can be a database related resource, right? So we'll collect all the logs individually for those resources in a separate centralized manner, and we will aggregate them. We will aggregate all those logs to create a common dashboard, and that is called SIM solution. Okay, so you'll collect logs separately, right, in a centralized account separately, and you will aggregate all those logs and create a unified view and present it to SIM solution. So that in SIM solution, the fundamental duty of a SIM solution is to analyze those incidents and find the root cause of it, right? Analyze and find the root cause. That is the SIM solution's key responsibility. It will not respond anything, right? Response is the responsibility of source solution, which is security orchestration and automated response. And to do this operations work, nowadays we are introducing AI. AI actually helps us to quickly detect those incidents and quickly analyze them, right? So one of the very beautiful examples is like, nowadays we are looking for like intelligent, security operations, where like if a company is doing security operations for like 15 to 20 years, they will have like a lot of documentations on multiple incidents that had happened throughout, right? Now if you can feed all that to an AI model, right, and an AI model will be trained based on those incidents, and currently if any incident is happening, it can immediately say like, 10 years back a similar incident had happened, and this was the resolution that was taken to mitigate that incident. So it will be able to quickly uh, correlate it to an existing incident, and it will be able to provide a resolution, right? So it is very useful for the threat intelligence and threat hunting. And we can also use AI to create automated responses, and it can also assist the analyst. So for actions that are very sensitive, right, privileged action, we need not like allow AI to do an automatic modification, but they will provide recommendations to the analyst, and analyst will take a final call. So that is AI for security monitoring. All right. So with this, we have talked about all the common shared services like, your identity and access management, and about if the security monitoring. Now we'll go into resource-based logs, right? We'll talk about infrastructure and network. We'll talk about app security, data security, workload security, right? In the next four domains. Moving on to infrastructure and network. So infrastructure is where like we are renting only the infrastructure from the cloud service provider, while we will take care of the operating system, application, and data on top of it, right? So organization is responsible for application, operating system, and data, while provider is responsible for the underlying infrastructure. It is the cheapest model. It is the most flexible service model, right? IaaS is the most flexible service model. So talking about infrastructure security, it comes since you will want most of the services. It is very important to have a secure architecture. So you can design the architecture, you can define the architecture, right? You are just renting only the infrastructure, but on the VM, on the application, the OS, everything can be defined by the organization themselves. So that can be effectively done with the help of secure architectures, and that security architecture is primarily driven by these two concepts called security by design and security by default. Security by design is instead of doing a security testing after the development had happened, right, like SAST or DAST, instead of doing it during the development, like code reviews, we need to include the security in the design stage itself. That is called security by design. So one effective way to do that is by doing threat modeling. So threat modeling is a activity that happens at the design stage itself, and it will create a security and it helps you to identify the threats at the design phase itself. And by knowing those threats, now you can uh, take a corrective action, right? You can implement the relevant controls to those vulnerabilities or threats identified in the design stage itself. So that is secure by design, and the other one is secure by default. So by default, when you install a database in, let's say, like cloud, right? By default, no one will be able to access the database, right? So that is called security by default. You create a database, but it will be no one will be able to access as long as you whitelist an IP address, right? No one will be able to access. So that is security by default, right? The same thing can be applicable to any like vendor specific tools also, like firewall, right? By default it will like unless you change the default credentials, it will not like work. Okay, so that's one of the secure by default controls. So security by design will be done by the enterprise architects before the development. Secure by default, they would have configured something, and when the end user by the end user when they start consuming the product, they need to change, right? So that is security by default. And then it's not about design stage itself, we need to have a secure deployment also, right? We need to have a pipeline which will do the SAST, which will do the dash testing to ensure our code is free from vulnerabilities. And if you're using containers, then it is like properly vulnerability scanning has happened. It is only signed images that are allowed for production deployment, right? All those deployment and configurations must also be taken into consideration. And after it is deployed, we need to continuously do the monitoring, right? We need to monitor them to make sure that the resources are working as expected, right? The controls are working as expected, they are deployed and operating effectively. So some of the CSP's responsibilities when it comes to infrastructure are they will take care of the facility protection. See, nowhere they will give you access to their facilities, because they will serve like hundreds of customers. It is impossible to allow all those customers to visit their facility. So the facility security is basically CSP's responsibility. The employees of CSPs, their responsibility. The components, the storage components, the network compute, they are again like responsibility of CSP. Virtualization layers, management plane, right? Management plane will be designed by CSP, and then they will provision it to a cloud service customer. And PaaS and services again like will fall under the responsibility of CSPs. And to provide infrastructure resilience, right? They have like three levels of redundancy, which is called like single region resiliency, which is called zone redundancy. So if you take like US East region, it will have like one or more data centers, right? And those data centers in cloud world is called availability zones, right? So if you take like US East, that is a region. Inside that region, there will be like three availability zones: AZ1, AZ2, AZ3, right? When you want your application to be zone redundant, you will have one copy on each of those availability zones. and that is called zone redundancy. So that even if availability zone 1 in US East is down, your application will still run from AZ2 and AZ3 within the US East region. So that is called zone redundancy. Even if one availability zone is down, it can continue, the application can still run due to this zone redundancy. But the limitation there is if like if the entire region is down, if US East is down, then your application will not be able to run. To make that happen, right, what they will do is they will have like one copy, they will have like US East availability zone 1, they'll have one copy, and in US West availability zone 4, they'll have one more copy. So that if availability zone 1 is down, it can automatically switch to the another region, secondary region, which is called geo redundancy. Okay, if US East is completely down, right, due to like a natural disaster or due to some power outage, right, then the services can be automatically shifted to US West, right. So that is multi-region resilience, also known as geo redundancy. The third one is the one multi-provider proficiency. I'll have like CSP1 for my primary, I'll have CSP2 for my secondary. So that it will have like issues with compatibility and all, but if you do a proper testing, this will give you like the best resiliency. Even if one of the provider is not available, right, due to like if they ran out of business or if there may be any issue, if even if one company is completely shut down, you can still continue your services from another company if you have this multi-provider resiliency, which is also known as multi-cloud. And the networking is basically taken care by software defined networking. Okay, so software defined networking actually defines the cloud networking concepts. Okay, so what it basically does is generally you will have something called controller. Controller will take the instruction and manage the infrastructure devices, the data devices, right? So this was our traditional networking. So you'll have a controller, controller will manage the network devices, right? Now, with the help of APIs, we have created one more layer called application layer, right? Or management layer, where users can say, generate instructions. Users can define instructions there. Like I can go and I can say like enable open port 80. So that will be a rule which I'll give at the application layer. In my UI, I'll give that control of enable or open port 80. That will be carried through API, REST API, and the same instruction will be passed to the SDN controller, who will get that instruction and who will um, reach out to that network device for which I have configured that provided that configuration, and it will open port 80, right? So that is software defined networking. Using a software, I am defining the network configuration of my infrastructure, right? In a portal or in a console, whatever rule I'm setting, that is carried by API going to the SDN controller. SDN controller gets that instruction and they are interacting with their underlying devices to make that change happen, and then it will respond back to me. That is called software defined networking, right? It has like three layers: application layer, control layer, and forwarding layer. Application layer is also known as management layer. Forwarding layer is also known as data layer. And the communication between application layer and control layer is called northbound because it is exposed to the internet, while the communication between control layer and forwarding layer is called southbound. Okay, and all these protocols are controlled via open flow. So the all these activities are generally managed via a protocol called open flow. Okay, so this is software defined networking. It is one of the very important concepts when we talk about the networking in cloud. And these are the components available in SDN, and SDN is one of the examples of your attribute based access controls, right? And so it is virtual networks. It has like subnets. You can set up a subnet at private and public. So these are some of the activities which you can do it in the console, which will be in turn converted into a network activity or network instruction. Right? You have route tables. You have like network security groups. You have network access control list, load balancer services, internet gateways, endpoints. All these can be defined via your UI itself, via portal, via console, and that will be consumed or taken to the SDN controller, and the corresponding activity will be done at the data layer. And some of the network security measures that you can have, right? One is preventive is your firewall, right? Before even it enters the organization network, we can look at a malicious traffic and you can block it, right? It can be either a WAF, web application firewall, which will look at the URL and block the URL itself, or it can be a traditional firewall, which will look at the URL, wait for it to be converted to packet, and then filter the packet, right? And but if it is not happening at the preventive layer, second, the attacker may get into your network and you have to detect it. The detection can be done via analyzing the logs, right? Flow logs or DNS logs. You'll go through the logs and then you'll detect, oh, a suspicious incident had happened, right? An expired account, right, has logged in, right, or disabled account has logged into your organization, right? You can go through the logs, identify, detect, flag it as an incident, and you can analyze that, right? And one of the very important tools that actually help you in this detective is your sim tools. So sim tools will collect all the logs, the in the log aggregation manner, and it will provide you a unified view so that you can know who is the actor and what is the impact due to that attack, right? This is second control. The third one is corrective. Now that it is detected, we need to correct that, right? We need to remediate it, we need to mitigate it. To do that, we can have certain controls in network like DDoS protection. You can also have like SOAR tool, which is like automated response tool. So these are the three control types that are available for your network security. And another feature of the infrastructure is you can create IAC tools. IAC is infrastructure as code, right? Instead of, see, I am creating a VM, right? uh, like I'm making all the necessary configurations to make it compliant to my regulation, to whatever regulations I am need supposed to adhere to. I'm making all the changes to that VM infrastructure, right? It is rock solid, right? So now if I want to move that to test environment, ideally, if I don't have IAC, then I will again like create a VM. Again, I have to spend like 1 or 2 weeks to make it compliant, right? The similar way, I have to do an environment setup in production environment, right? Which is time consuming. Not just time consuming, it is also prone to error, right? Whatever I did it in, one environment cannot be replicated manually in the second environment also, right? To avoid all that, what you can do is you create one environment, you create a resource in one environment, send to security team for security review, send to compliance team for compliance review. Once all of them approved it, convert it into a template. That is called IAC. And once you convert it into a template, you can deploy it uniformly across all the environments, right? Across regions, across environments, you can deploy that. So that is the power of IAC. It will give you a uniform, consistent, secure resource every time you're trying to launch, right? The best feature about that is it is declarative. You can define it via syntax, right? And it is idempotent. Idempotent is, I have like three VMs now, right? In my template I'm specifying it as three VMs, right? Tomorrow I'm changing it into four VMs, right? So my expectation is it should add one more VM. So that is called idempotent. So it is running three VM. Now I'm deploying a template saying four VM. It should not add four more VMs. Right? It should always monitor at my current environment, and based on my current environment, it should identify the drift and it should take an action based on the drift. So that is called idempotent. Right? Three servers are running while the template says five servers are needed. It should not add five more new servers, right? It should add only the two more servers, and that is done with the help of idempotent, which is another feature. And the benefits are like you can do an automated complaints check, right? You can do an automated complaints check. You can have a consistent security posture across environments, and you can do a rapid rollback. So if I'm doing a latest library update, that library has vulnerability or the uh, update is not successful, I can immediately roll back to the previous because it is defined in a template. I can just go to the template, I can change it to a previous policy, and that will apply that to all the resources. So these are some of the benefits of IAC. One of the very popular tools is Terraform, which is a very popular IAC tool. You have like CloudFormation in AWS. You have like ARM, Azure Resource Manager template, and Bicep. That is another feature available in Microsoft to help you with the IACs. And we also need to look at the zero trust option. So when we talk about networks, right, it's very important to uh, understand about the zero trust. So zero trust actually always enforces you on the micro segmentation part. So it don't want to provide an umbrella access to all the users who are logging in, but only the least privilege access that is required, right? That is done or driven via these two concepts. One is called software defined perimeter, where you can logically set up perimeter, right? That a user, they will be able to access, like previously, right, traditionally when you connect to VPN, you'll be able to access everything within the VPN, access whatever is allowed by the client, environment to do. But nowadays it is restricted, right? You'll be given access to only specific resources which you need access in the VPN. So that is defined via the software defined perimeter. And the other one is zero trust network access, where like every request will be validated, and only if you have access, it will allow you to perform your actions. Otherwise, it will block you. So that is zero trust network access. So these are the two ways by which we can enhance the security for the networks. So you can enhance the security of infrastructure using IAC. You can enhance the network security using software defined perimeter and zero trust network access. And another way to enhance the security is by introducing SaaS. SaaS is like secure access edge server. So instead of managing it in a centralized way in a location which is far from the endpoints, the control will happen at the endpoint level itself. Right, the security filtering will happen close to the user by having a centrally controlled endpoint agent. You will still have the centralized control, but the agent will not be deployed in the centralized way, but it will be deployed close to your endpoint devices. And you will also have a global network of points of presence. So this will help you in mitigating the wait time, right? So if your endpoint agent is located in a centralized way, I am logging in from Australia while the endpoint is in US, right? So to make that verification, the traffic has to hop from Australia to US and then verify it, and then it has to come back to Australia, which is called like backhauling or hairpinning. To avoid that, SAS, what it will do is the monitoring agent, monitoring engine will still locate in US, but the endpoint agent will be in Australia, and it can closely verify that, right? It can quickly verify that and provide access. So that is called SASE. Now that we have seen cloud infrastructure and network, we'll look at the PaaS security, right? PaaS, there's like two ways. One is the workloads. So it can be either the applications that you are developing or the containers or the database. And also it also talks about the application level security. All right. So when we talk about workloads, so what is different in cloud? Obviously, so cloud compared to your on-prem, it is very dynamic, right? So you can make any changes, with any configurations that you want, and it is expansive. It can be loaded anywhere, and it is very complex, and it is also diverse, right? Any configuration it can work, and it is emerging. There are like new types of workloads that actually come, every now and then. So we need to understand the new types of workloads also, like serverless, right? So we need to understand them, and we need to see what best should be applied for our environment. And how can we actually add the security controls for that? So we need to enforce the controls. We need to look at the application holistically, and we need to enforce the control. We need to monitor them. We need to assess, whether the controls are operating effectively. That is very important. So at a design phase, we can, uh, do all these types of controls, and but we once it is deployed, it must be continuously assessed, right? And audits are a very audits and KPIs are two of the very important controls that will help us with that. KPIs or like goals, it will capture, and it will be captured by the operations team, and it will be sent across. And the last is CWPP, which is cloud workload platform protection. Just like CNAP, which is for native application protection, this is for the platforms. And some of the risks that are associated and the controls relevant to that. So you need to always go for base images, right? Base images as in like go for immutable images, right? So when you deploy image, there should not be any modifications that will be allowed per se, right? So only if you allow authorized person to do modification, then hacker will use the same privilege to do an unauthorized or unintended action, right? So instead, you should create like a secure immutable image so that there are no modifications allowed, and the base image, which is considered as the golden image, it must be as secure. So we need to go through security testing, it should go through vulnerability testing, it should go through vulnerability scanning, it should go through compliance testing. It should be as secure as possible so that any copies that are derived out of this base copy will also be secure. And we should have a strong robust patch management process. Again, we need to look at the shared responsibility model, make sure who is responsible and whether they have very strong like patch management process for that. We need to avoid attack services, minimize the attack surfaces as much as possible. One such way is to disable or remove unnecessary library files or softwares to make it like very we should not use bloating images, but we should use only the library files that are required, right? And then access controls, and then we will also focus on automation like IAC. You can use an IAC configuration management, and you can use monitoring, logging, the network security to harden the SSH, right? And you should have like a secure boot using TPM, trusted platform modules, and VTPM, virtual TPMs in cloud. And you should also use specialized security tools, right? We cannot just rely only on our on-prem security tools because they may not be compatible here. So uh, we need to go for security tools also, specialized security tools that are very specific to our cloud tools as well. Okay, and this is how like we will create an image source, right? And we will take it from like when you create a VM or when you create a EC2, we will select that from one of these image sources only, and from there you will create a secure image. And once you have the secure image, you will be once it is a secure image, it will be signed by the developer, and the images that are scanned and that are signed will be called as the approved images, and they will be used for deployment, right? So you create an image, right? Image will be stored in a container registry. Container images will be stored in a container registry. So when you want to deploy, you will pull that registry using image factory. You will pull those images, right? And you will be doing vulnerability scanning there, and you will also like create a secure image on that, and you'll use that to deploy. Okay, so that is how we will kind of do the security for the containers. Okay, and some of the tools that can help us, again, like cloud workload platform protection will help us. Our traditional vulnerability scanners can help. Configuration management tools like IAC or to identify the drifts, it can help. Endpoint detection and response, and SIM solution, all these tools can help us to secure the VMs. And just like having a secure VM, it is very important to have a backup of those VMs also. So snapshot is one of the way in which we can take a manual backup of it. So it will not just store the configurations alone. It can capture the VM state, files, settings, and everything associated with the VM, so that at any point in the future we will be able to restore it to this current state, and we will be able to do the forensics related to that. And to uh, just like the protection we give to VM, the same level of protection should be given to these snapshot images also. Otherwise, it will result in like unauthorized access and data leaks. So to mitigate these risks, we need to have a very strong access controls, right? We need to restrict access to people to create those to access those snapshots, and also to retrieve should be done only by the authorized person. We need to encrypt the snapshots, just like, treat it like any other confidential data, so it has to be encrypted at rest and in transit. And we need to always regularly review and delete also unnecessary snapshots. So too much of data will result in a lot of liability, so we need to regularly review it and delete all the unnecessary snapshots. And the last thing is to always have an monitoring tool which can monitor the unauthorized accesses. Okay, and as I mentioned, just like the protection you give to a live VM, the same level of protection must be given to the snapshots also, because if a snapshot can be compromised, then they will be able to easily reconstruct the original VM. And if they are able to reconstruct the original VM, then they will be able to expose all the data that are present associated to that. So it is very important that we protect both the live VM and the snapshot in the same secure manner. Next step is to secure the containers. Containers are like a lightweight virtual machines. The only difference is in a VM, the application and the guest operating system are tightly coupled, or it is mapped one to one, which means one application can run in that particular operating system. That's it. Which makes the portability very difficult, and because of which we will kind of create the library files and the environment every time, and then we will deploy only the source code, which again will not run properly. So to avoid all that, we have a concept of containers where the moment a developer successfully executes the code, right, along with the source code, we'll package the library files also, and we will convert it into a container image and put inside a container. This container, if you take it anywhere and if you deploy, it will run, right? And instead of having it as a monolithic application within your VM, we will have it as a microservices container. Multiple containers will be integrated to form an application, right? So that now, if there is only one container or one service which requires more traffic, we can scale only that particular container alone. Or due to some power issue or network failure, if any one of the services is down, the other applications will be running, right? So that is the advantage of using containers. And how can we secure those containers? My formula for securing containers is container security equal to scanning plus signing. So whatever container image you have, that should go through vulnerability scanning periodically and at different stages of the container lifecycle. If you're going to deploy it in production, before deployment you should scan it once, right? At the starting of pipeline, when you're actually pulling that image, you have to scan it. So scan for vulnerabilities um, every time. So that is one. Second is, once the developer has developed, they should sign it, right? So if they sign, it means like it's a valid uh, container image, and we can use it for deployment. So before deployment, we will check, we'll do a vulnerability scanning, make sure it doesn't have any vulnerabilities. We'll check for signature to make sure it is a valid container image, right? So container image creation, so we should use like secure base image. So we should have only immutable infrastructure, so no modifications allowed. Instead, it is very easy to create an additional version, right? So that is containers. And the artifact repositories must also be secured properly, and networking must be properly aligned, right? So it should happen at multiple levels, from individual containers to load balancers. There will be like multiple network rules that you have to set. We need to set it properly. So that's how we can secure the containers. So some of the other ways to enhance container security and the container images are just like the ones we see always use the secure source, pull it from the official galleries and repositories, sign the images once you create, and use that signature to verify the authenticity of that, and always scan the image multiple times throughout the life cycle. Restrict the access while it is stored, while it is being deployed. Maintain a proper audit trail for the same, and continuously update the repository softwares. So these are some of the key tips by which we can secure the containers and in the registry as well as while we deploy. And some of the runtime protection, now we have pulled the container image, we have deployed it in the website. How can we actually protect those containers? Again, continuously monitor them after deployment. Just because we deployed doesn't mean we have to stop monitoring it. We have to continuously monitor them for any unusual behavior. Always keep a track of the logs and the audit files. Segregate the containers to prevent any unauthorized access. Even if a hacker or a malicious person is able to take control of one of the containers, if they are isolated very well, then the impact will be very mitigated, right? Always try to have a container specific firewalls, making sure that the network traffic is filtered and only authorized traffic is allowed, and try to create automated responses so that as and when an incident happens, immediately we will be able to isolate and we will be able to mitigate it. So those are very important when the container is in runtime after deployment. So we talked about containers, right? So containers, where you have each container will represent a service, and a combination of all these services will form the application, right? But it is not feasible for a human to continuously monitor those containers, right? We need to try to automate it as effectively as possible. And one such important service which can help us with the container orchestration is called Kubernetes. Kubernetes in Greek actually means captain of the ship. So they will order where to place the Docker container. They will order how many Docker containers must run. So they are generally in charge of the ship. So similarly, the Kubernetes here will monitor all the containers, right? And let's say there are three containers that are supposed to run, but there is a very high traffic at that particular microservices. Then based on the configurations, they can add two more containers to support that extra traffic. In another use case, there are three containers that are supposed to run, but one failed due to like network failure or power outage. In that case, Kubernetes will provide instructions to run one another instance version of the container. So that is what a container orchestration will do. And it is very important to secure that container orchestration just like we secure the containers. And some of the key security pointers related to that are to use cloud service provider services. Try to use the cloud service providers tools for your security. Harden those services, like disable all the unwanted services, remove all the unwanted libraries, right? Use only the secure base images and enforce those network policies. Regularly patch and update all the components, and implement the Kubernetes security and network policies. Along with cloud service provider, you can create Kubernetes specific security and network policies. So we'll try to filter, we will try to enhance our security by doing that. Have like a proper benchmark and tools, and secure the image repository when the data is stored. You can try to store secure those image repositories. Have like a very robust secure configuration, and which is like very well automated, and if there are any changes, that drift is noted, and it is looked into. Have like host security of the operating system level. At the We need to harden all those host operating systems, like again like disabling the services, deleting unwanted components and everything. And the storage security, data at rest, data in transit, it should be completely encrypted. Access control must be restricted, and the access must be continuously monitored. It should have a proper network security, and the images of container that are going to be deployed, it should be validated with a vulnerability scanning, and the signature must also be verified. These are some ways by which we can secure the container orchestration. So now that we have seen container, container security, artifact repository security, and cloud orchestration security, we'll also see another cloud emerging service called FAAS, which stands for Function as a Service. The best example that I can give you is your Alexa, right? When you say Alexa, the machine turns on, and then it will perform the instruction that you are giving. It may be like playing a song or some any instruction. It will do that particular job, and after that, it will again turn off. That is an example of function as a service. Instead of running the entire microservice, we are just going to execute that particular function only when it is triggered by an event or in a scheduled manner. And it is also very important to secure these functions as a security, because these are generally called serverless, which means by default they will not run on any server. Only when an event is invoking it, at that time the cloud service provider will provide the appropriate infrastructure. So it is very important to understand how serverless actually works, and we need to secure that serverless computing also. Again, serverless doesn't mean we don't want server. It is not without servers, but we as organization are not managing any underlying servers. It is completely managed by cloud service provider. When an event happens, the cloud service provider will automatically provide the cloud services which can be consumed for the function to execute, and then it will again turn off. So the with respect to security, this function as a service is heavily dependent on the third party services and APIs. So we need to restrict the attack surface so that if we fail to do that, it will result in more vulnerability. It has vulnerable dependencies, Again, we are not managing any underlying infrastructure, so we are we may look for external libraries which may result in vulnerabilities. There is a good possibility of misconfigurations happening resulting in over permissions, or it can be a overly privileged IAM, or it can be the direct internet access. These are some of the security issues which must be addressed if you're planning to consume function as a secure service, or which is also known as serverless. So some of the controls for that security risks are: one is to have the least privilege access. Just like any other component that we have seen so far, we need to restrict access only to those people who need access to that function. It should be fine-grained access control. So even within that function and people who have access, we need to provide them the appropriate permissions. Like, remember, the owner, developer, reader. So we may need to have fine-grained access control related to that. And it should be a context-aware authorization. Context-aware as in, like, you it is basically the conditional access or the policy based access control that we saw, right? So if you are logging in from your device, then you can access the services without any MFA. If you're logging in from a different device, then there will be an additional verification. So that is context aware authorization. And it should be immutable infrastructure. So just like containers, there are like no modifications that are allowed, right? If an authorized person is unable to modify, then a malicious hacker will also not be able to modify, because that is not in the design itself. So that is what we are trying to achieve. And even in functions, just like containers, we need to have that immutable infrastructure, and whatever secrets required for the function to execute, those must be managed efficiently. And those credentials again must be rotated periodically, so that the amount of exposure will be less when it is compromised. And last is to review and update the IAM policies. We need to regularly go through the people who have access, and we need to remove if they no longer require access. So that must be done periodically in a scheduled manner. These are some ways by which we can secure the serverless computer or function as a service securities. So moving on to Cloud Security Alliance Large Language Model Threats Taxonomy. If you don't know what large language model, it is where it will be trained on a large data sets in terms of billions and trillions. And based on that, now after it's trained, it will be able to generate its own text, generate its own image, and generate its own code. The best example is OpenAI's ChatGPT. It's some of the risks with respect to those large language models or model manipulation, where the model is, you know, through malicious prompts, the model started to behave like weirdly, and it is unable to predict accurately. Second is data poisoning, where the input data is poisoned due to malicious prompts, and it inverses the model behavior. Sensitive data exposure, we will kind of send prompts in such a way that it actually um, manipulates the training, and it starts revealing the sensitive data with which it has been trained. Model theft, model failure or malfunctioning, insecure supply chain, insecure apps, denial of service, and lack of governance. So these are the large language model threats taxonomy that is designed by Cloud Security Alliance. And these controls, those are not part of the syllabus, but I have added it just so that you can have an idea on how to control them. Right. So for model manipulation, it should be robust access control, and we need to monitor and log the model interactions, how it is behaving. Right. For data poisoning, secure the training data sets. That's very important. Secure the training data sets with encryption. So validate those data inputs. Sensitive data disclosure, make sure that the data is encrypted, right? And strict access control. For model theft, again, use encryption for model storage and apply the IP protection techniques, and monitor for unauthorized access. And for model failure, conduct rigorous testing. It can be identified in the testing phase itself. So conduct rigorous testing, establish the monitoring mechanism, and implement fallback or redundancy. And then for insecure supply chain, verify the integrity of components, right? Wherever you see insecure supply chain, if you want to verify the authenticity, always go for the integrity, right? Like convert it into hash, make sure that the hashes are matching, right? And then go for insecure apps, you have to do again the security testing. For denial of service, this may cost due to like APIs, so deploy the rate limiting and have WAF and dynamically block those IP addresses to mitigate the DOS attack. Loss of governance, audit the cloud environments for regulatory compliance, implement the policy enforcement tools, and maintain the updated governance framework. These are some ways by which we can control the threats in the cloud environment that are caused by large language models. And some of the AI risk mitigation and shared responsibilities. For data security, we need to have encryption, we need to have differential privacy, we need to have secure multi-party computation and confidential computing and model hardening. So differential, you need not know all these terms in detail, but just having a high level understanding is fine. So differential privacy is where like we will add some noise to the training data set so that it is becoming very difficult to understand what the training data is actually used. So hacker, it becomes impossible for the hacker to guess or extract the training data set because we will add a calculated noise to the training data sets. Secure multi-party computation. So instead of like exposing all the data to all the parties, we'll combine and we'll create a new version so that we will not be able to identify other person's data. So that is secure multi-party. Confidential computing is where we will create a separate isolated container in which the processing will happen in such a way that the data or everything at in use is also encrypted. So that is confidential computing. Some of the model level security are like you need to have like robust training of the model, and we need to have like adversarial training. We need to proactively do some red teaming testing on the prompts to make sure that the model is not leaking any sensitive data. Model watermarking is there. It's like a digital watermark to the model to make sure that no one else is actually manipulating the model, and output manipulation must also be monitored. With respect to infrastructure security, we need to secure the GPUs and TPUs that are used. AI services, again, most of these will be accessed via APIs, so you need to have quotas and rate limiting. We need to secure the channel in which the data is transmitted, access management and monitoring and logging. And for supply chain policy, we need to have policies, risk management, vetting services, trusted sources, source code scanning is very important, contractual security clauses, version control management, and supply chain threat intelligence. These are some ways by which we can mitigate the AI risks that are introduced uh, in the cloud computing. And we also need to care about the shared responsibilities. If your organization is consuming AI, which is actually leveraging cloud, right, then we need to care about cloud responsibility as well as those AI responsibilities. Okay, with that, we have completed the workload protection. Next is data security. As I mentioned previously, the popular saying says, security follows the data. We have all these security controls for one objective, that is to protect the data. So we need to identify where the data is located. We need to classify them, and then we need to implement appropriate controls across the data lifecycle. So that is the responsibility of data security. So when we talk about cloud storage, there are different types of storage options. It's not just your typical disk storage alone, right? Which is called volume storage here, right? You have volume storage. Whenever you create a VM or EC2, there will be a disk that will be created along with that, and you can store files in those disks, right? You can restore them and all. So that is only one part of the storage type, which is volume storage. Along with that, the most popular cloud storage service is called object storage, where you can store bulk or large files within the containers. The examples are like S3, which is simple storage service in AWS, or blob storage in Azure, right? So and most of your streaming services basically leverage these cloud storage options, so they'll store all their movies and pictures and videos and everything in those containers, and through API now the end user will be able to access those containers if they have appropriate permission, in this case the subscription. And so that object storage is an example of unstructured data. Just like unstructured data, we have some structured data that can also be stored, like uh, customer details, right? Name, phone number, address, pin code, right? So that will be stored in a relational database. And between relational and unstructured data, structured and unstructured, we also have semi-structured data, which is also stored in those storage services. And there are some other storage services like logs getting stored, right? A log is aggregated, right? You will have like a workspace dedicated to collect those logs. So these are different cloud storage options. But as I mentioned before, whatever data is getting stored in cloud, it will be encrypted by default, right? No questions asked. The only question is whether it is encrypted with cloud service provider's key or whether it is encrypted with consumer's key. That is the only question. But all the data that is getting stored in cloud will be encrypted because most of the consumers are worrying about the multi-tenancy. Multi-tenancy is always a concern. So to mitigate that concern, we always encrypt the data and send it. Okay. So we'll see about the data security tools and techniques. So as I mentioned, the first step is to discover the data, where it is located. Once you discover the data, you will classify them. Once you will mark it as a sensitive, or you will mark it as a public, you will mark it as a confidential. So we need to apply a label, okay, to the data. Once you apply the label, now you will you will restrict the access based on identity and access management, right? You will say like this person can access database, right? And what is the permission, whether they are admin or developers or auditors. So based on that, the access policies will be built around that, and we will also have encryption and key management, right? So the data will be by default encrypted, but who will provide the keys? Is it provider or is it consumer? That we have to take control. And the next one is for SaaS services especially, we will also have a data loss prevention option. So data loss prevention will ensure that the sensitive data is not leaving the organization, right? We cannot kind of once the data moves out of our environment, it is very difficult to trace it back or restrict it. So we will have an egress controller or egress monitor which will monitor all our outward traffic, outbound traffic, and if there are any sensitive data that is shared, it will filter right there. It will block the transfer from organization internal network to the external network. So that is done with the help of DLP. And some of the layers with respect to uh, cloud data encryptions, or like you can encrypt it at any place. So I was talking about encryption and all the data getting encrypted, right? So there are just right here, there are like two use cases, right? So either I can upload a plain file, and while I'm uploading, the cloud provider can encrypt the data. That can happen, right? Or I'll encrypt the data, right? And I'll upload that encrypted file to the cloud. That is another option, right? So these are different ways by which the data can be encrypted. Either I can upload a file and encrypt it on the run while uploading, or I can upload an encrypted data as is, right? And higher the granularity, higher will be the complexity. The more um, specific we want to encrypt the data, the more it becomes complex. Okay, so and we need to make sure that the data is having that much value to actually go for that level of granularity. So if your data is worth, if it is a public data, you need to spend a lot of granularity or complexity to protect that public data, right? You can just use like a like entire like shared drive encryption, right? Disk level encryption. You can just do a disk level encryption where all the public data is encrypted with one key. That is fine. But if it is a database containing sensitive information, so for that individual tables, you can generate individual keys and use them to lock. Right? That is granularity. By increasing the granularity, the complexity will increase. But all these are dependent on the value, criticality, and sensitivity of the data. Okay, only if it has a high value, or if it is highly critical, or if it is very sensitive, then we will go for the higher level of granularity and complexity, right? So at the bottommost in stack is volume or object, right? The files, disk storage or object storage that we are talking about, right? So it will be like one key which will encrypt the entire object, the entire disk encryption, right? So for D drive, it will be only one key which will be used to lock that entire volume, right? I don't want to apply it for the entire drive, but I want to apply for a specific file alone that is more granular, right? So that is called file level encryption or API based encryption. Only for that particular file alone, I'll apply the encryption. I can restrict access, like who can access the file or not. So that is file level encryption. And on top of that we have database, so where I am storing the data, and I'm for the individual table there will be individual keys to lock the table and data, so that is database. And the last one is I don't trust database. So the problem with database is all the records in that table will be encrypted with the same key. I don't want that to happen. I have like sensitive files like social security number, right, or card number, right? I don't want the same key to encrypt my non-sensitive file and the sensitive file. So to prevent that from happening, I'll go for application, where as soon as the user is entering social security number or their password, it will be encrypted right there, and the encrypted text will be sent to the database. So that is application. That's like the highest uh, granularity that we can set, and it is highly complex. So instead of sending to the database, and during when we are inserting to the database, when we actually encrypt, we will encrypt that particular file and then send that encrypted file to the database. So that is application. So these are the different types of data encryption layers that are available, right? Based on the criticality, sensitivity, and value, we can select the appropriate level of encryption. We'll see the different cloud data key management strategies. So from the beginning of data security, we are talking about two use cases, right? Where one, the data is encrypted by the client, and we are uploading that encrypted data, or we are uploading a plain file and the provider is encrypting the data. So those stand for the first and two. Client side encryption is where like it is already encrypted, we are uploading the encrypted file to the cloud. Server side is a plain file that is uploaded, and the cloud service provider's key is used for encryption. The third one is customer managed encryption key. Here the encryption will be done by the provider, but the control of that key will be managed by customer. Customer can set the key rotation period. Customer can set like which keys can be, which data can be protected using those keys. So that is customer managed. The other one is customer provided encryption keys. At the time of encryption, customer will provide the key. They'll store the key in the key vault and refer that key to lock the file, right? So it's a plain text, but customer is providing the key to encrypt it. So that is customer provided encryption keys. The last is custom application level encryption. Instead of doing it at the runtime, right? At the application level, we will configure the encryption just like social security number or credit card number, and we will encrypt it at the application and then push it to the database. So that is custom application level encryption. And some of the data encryption's best practices are always store it in key management system, right? Do not write it down, do not store it in a plain text notepad file, but store it in the KMS, and store the key separately from the data. Do not store both data and key in the same place, because if key is compromised, then the data will also be compromised, right? And for SaaS considerations, always mostly on, you will be like always dependent on the provider for data protection. So we need to be more monitoring the provider side tools for the data protection. Okay, and we should always, like, by default the data must be encrypted, and you can use like different keys for different services. Look at the IAM policies, because they actually drive those key management, and always try to align with the threat models, right? So threat models based on the vulnerabilities, you can align your data protection. So one of the key concepts with respect to data security is to track the data lineage, right from the entry point right till the exit point, the data must be tracked. That is called data lineage, right? And in data lineage, like, the data is getting discovered, or and then it will be classified based on the sensitivity, right? Once it is classified, in classification you'll apply a label, and then it will move to the store phase, where the data will be stored, and it will be encrypted using symmetric key encryption, AES 256, right? And then it will go to the use phase. Data will be in the RAM memory, data will be accessed. So you will be using confidential computing or DLP to protect the data in the RAM memory, and then the data will be now shared, right, to another device or another application. So the data will be in transit. For transit, you'll be using asymmetric encryption, TLS 1.2 or 1.3, right? And then will be the data will move to archive stage after the infrequent access, right? And it should have the same security as the storage phase, right? Similar symmetric encryption AES-256. And at the last stage, data will be deleted, right? It should be logically securely deleted, and for that we'll be using cryptographic eraser, right? So the data security means the data must be secured throughout the life cycle from the entry point to the exit point. But one of the challenges is when we actually overprotect the data, right? We'll have like overlapping controls so that the same data will be protected by two or three controls, which is not required, right? To avoid all that confusion and to have like the appropriate level of control, we'll be leveraging the data security posture management. It discovers the data, it applies the label, it will look at all the IAM policies and the overlapping controls that are used for protecting the data, and then it can visualize who have access to data and how they will access the data. Based on that, it will offer remediations, right? How we can um, remediate and have only the appropriate level of controls, and it can also like create some IAC templates which can be used to apply the controls for the data. So this is one way where DSPM helps us to provide the appropriate level of control for the data security. And for storage security, as I mentioned, object storage is where you can load a large number of files which are like of very huge size. Like most of your movies, streaming services, they leverage this object storage, and it is very important to secure it, right? One way is like by default they will block all the public access. Like they will block all the public access, and they will provide access to people only who are like who need access to upload, as well as like who are asking for subscriptions, right? And whatever data that they have, it will be encrypted, and that encryption will be uh, keys will be stored in the KMS, and they will leverage the KMS to keep the keys secure. And they will also leverage something called content delivery network. Content delivery network is not security specific, but it is more from a performance side, user experience side. So it will make sure that the data that is stored in private storage will be exposed to only to the limited public access, and always it will be continuously monitored, right, using cloud security posture management and data security posture management for maintaining the security. It's a commercial tool, so we need to have all the security controls intact to protect the data security. And we also need to consider the data security for artificial intelligence, right? So if you are starting leveraging the artificial intelligence, then we need to make sure that we have well written policies, right? Data deletion, with respect to data deletion and retention, we also need to understand the data flow, the data lineage that I was talking about. From creation phase till deletion phase, the data lineage must be tracked properly. And then we also need to evaluate the providers AI security measures against adversarial attacks. What are all some of the native cloud security services that are given by the provider to protect our data? And we also need to understand the SLAs, SLAs and security practices, so that we can negotiate it and we can deploy the controls that are required to protect the data. Right, so with this, we wrapped up data security. The last in this series is application security. So we talked about workload protection, we talked about infra network security, data security. The last one in that series is application security. What are all the testing that once the development is done before deployment, what are all some of the testing options that we have? So again, just like in the previous domains, we need to understand how it is different in cloud when compared to on-prem, right? The main challenge with cloud is the over usage of APIs. Right here in on-prem, there'll be like very limited set of APIs for specific functions, but when it comes to cloud, everything is done via APIs, right? So attack surface is actually having a significant exposure over the APIs. And applications are built on libraries, right? And that libraries may be, a vulnerable one, like a supply chain attack, right? Especially in a PaaS service, right? We will leverage open source libraries or any external dependencies that may be vulnerable. If they are vulnerable, the application which uses that library file is now vulnerable. If the application is vulnerable, the data stored on top of that application is vulnerable, right? So this is the main difference between your cloud and the on-prem, right? And we also like leverage third-party libraries, again like open source components, right? You have this thing called like SBOM, software bill of materials. Just like for any eatable items, you have the ingredients listed. For any like third-party SaaS softwares that you are purchasing, SaaS applications that you are purchasing, there'll be something called SBOM, which will list down the ingredients or the open source libraries that are present. So if there are any vulnerabilities in the library, now it will be easy for you to track the applications that will be become vulnerable due to the vulnerability in that uh, library. So that is the latest um, security component that everyone is talking about, SBOM, software bill of materials. And then you also need to have like identity management, logging, monitoring, all these. Like generally it will be now procured or outsourced from the cloud service provider, right? So which may not be suitable for the application requirements. So if it is a legacy IBM application, then you cannot expect your cloud authentication to serve effectively to that legacy applications, right? So we need to that is another challenge that we have. So not all the applications will be like cloud specific or cloud ready to migrate. Okay. And then next is we will again like deploy on the IAC format, right? It will be IAC, it will, everything will be automated, and it will be touchless or without human intervention, right? Which means if there is any like vulnerability which gets introduced at any point, it can smoothly get into the production phase if we are not because there are like no human interventions there, right? So we need to understand all the underlying cloud vulnerabilities for that. The stateless architectures again, FAS and all the containers, they are adding more complexity, which also may impact the application, right? And which are also get impacted due to the infrastructure failures. So these are some of the changes. One is like overusage of APIs and having this open source dependence on the open source libraries and components, and using the automated way of IACs. So these are the different stages of secure software development life cycle. So you will have like a secure design, you will have like a planning stage. Once the development starts at the design stage, where you will build some architecture, and the design stage, you can do testing by uh, performing threat modeling. So Stride is one of the very common example for threat modeling. And then you'll start developing the code. Once you have the design ready and approved, now you'll go into secure coding, secure development. So SAST will be very good source code review. It will do source code review. It can check the vulnerabilities at the development stage. You can do software composition analysis. You can also go for image and IAC scanning also to identify vulnerabilities in the source code. Once all the source code are like created, it will be integrated into components at the continuous in a pipeline. It will be like continuously building and integrating and testing the software components that can actually help us, or DAST, which is dynamic application security testing, which means we will test it in a black box manner. SAST is a white box. We'll go through the source code and identify vulnerabilities in the source code, but DAST is a black box testing. We will not test against the source code, but we will test it against the application, right? We'll test the functionality of it. We'll test if there are any security vulnerabilities when the integration had happened, right? A part of it, the additional version of it is called IAST, which is interactive application security testing, which is a combination of both SAST and DAST, right? We will understand the functionality and at the same time validate the functionality, and at the same time we'll look at the security source code also to make sure that there are no vulnerabilities present. Another important way by which we can identify the vulnerabilities and risks is by performing a penetration testing. So this is another way by which we can ensure that our source code that we application that we are going to deploy is error free. And we'll also like think about continuous delivery and deployment. The last is to have runtime defense and monitoring. So where like in production, we will continuously monitor it with the help of a tool called RASP, which is runtime application security protection. So it will monitor the application live in production for any vulnerabilities or issues. and based on that, it will protect the application. And the second one is to go for some bug bounty, so where you will call for all the ethical hackers, and you'll specify the scope on which websites they can actually test. So the hackers can sorry the ethical hackers, they will based on the scope, they will try to find the security vulnerabilities and report it to you, for which a bounty can be granted. So these are different stages of the secure development lifecycle and the testing components that are associated with it. And we also need to think about how secret can be effectively managed, right? So one thing is like you have IAM, and you will see like how when we are interacting with a client and server, how can we authenticate that we are talking to that authentic server, right? So that is done with the help of PKI, public key infrastructure, and where like that website server will have a X.509 certificate, which is a public certificate. So which means I have a public key, I'll take it to a certification authority and get it stamped that this certificate belongs to Shiva, right? And when someone is trying to access my website, I'll show this as a proof of authenticity, right? And so that end browser can communicate with my server, and a connection can happen, right? So that is the example of public key infrastructure, right? So you have a client here, right? You have a client actually has their own server. Now they are public key, they are showing it to the certification authority, and they get that X.509 certificate. Now they will store the private key in the key vault, and they will take the public key and they will have it with them, right? When any user is trying to access this website, this public key will be displayed and the website will be loaded on that. And this is another diagram with respect to app security, where like it talks about how we can effectively integrate development, security, and operations. So development, security, and operations. So you have like a server configuration and an image or container configuration. And when you get a source code, you will create an image, right? And then you will store it in the version control repository or container repository. From there, it will do all the security tests. It will be pulled to the continuous integration server. It will do all the security test, and once all the tests are passed, it will be converted into a manual master image, and that will go through the manual or automated acceptance, and then it will be deployed to the production. So this is how we can create a DevSecOps pipeline, uh, wherein the source code can move from a development environment to production environment without any human intervention, right? You go to a server configuration, sorry, you will start with source code you will be building a server or container configuration, and you will also build an appropriate server configuration. From there, it will be that container will be converted into an image, and it will be stored in the version control repository. From there, it will be pulled into the continuous integration server, where all the security testing, SAST, DAST, IAST, PT, everything can be done. Once all the security testing are passed, it will be converted into a master image. And once it is a master image, we can either have a human to oversight it and then approve it, or it can be accepted automatically. Once it is accepted automatically, it will be deployed into production. If it is a container image, then you have to make sure that the container is gone through a vulnerability scanning, and it is signed by a valid user. So this is how we can build a DevSecOps CI/CD pipeline. And the other way to protect your application is by implementing a WAF and a API gateway. WAF stands for uh, Web Application Firewall. It is primarily used to secure your web applications from URL based attacks like SQL injection, cross-site scripting, or cross-site request forgery. Wherever the URL is malicious, instead of waiting for the URL to be converted to packet and do a deep packet inspection, it will look at the URL and then it will block the URL right away. So that is the advantage of using WAF. And most of these communications are happening via APIs, so we need to authenticate those APIs. We need to filter those APIs. For that, we'll be leveraging the API gateways. And how these deployment can happen, it can happen via agent deployment, or a cloud provider will directly give that service, or you can take a WAF from third party marketplace, or there are certain companies which provide WAF and DDoS as a service also. You can just leverage them, right? And you can directly deploy them into your environment. So these are the different deployment scenario options that are available to the end user. With this, application security is also done. So now all the development and deployment is completed. So that doesn't mean our work is done, right? So there may be some incident that is happening. There is always some you know firefighting that always needs to be done, right? And we call that as incident response and resilience. So what are all some of the options with respect to incident response? We need to understand the incident response life cycle. So incident response is basically done by the operations team or production team, and for security it is called a SecOps, right? Security operations team. So we need to prepare the team, right? We need to create a team. We need to give them the roles and responsibilities, right? And then uh, the necessary skills to look for the incidents, right? And then there will be some incidents or logs available. So you will be detecting for those incidents, and then you will analyze. Right, one thing you have to confirm whenever someone is reporting an incident, we need to confirm whether it is a valid incident. That is very important. Once it is done, you will analyze it, and then first step is to contain it. So we need to prevent the spread from happening. So we need to contain it, right? And then you have to eradicate it. Eradicating is removing the threat source, right? And then recover, restore it to the normal operations, right? And then do an analysis on what went wrong and if there are any improvements throughout this incident response life cycle. So that is very important. So preparation is fine, and once you prepare, there'll be some incidents. It can be either detected or it will be reported. You will analyze whether it is a proper incident. Once it is a proper incident, right? Let's say um, if a system is impacted, the first thing you will be like isolating it from the rest of the network. So that is containment. And then you will find the source, right? So a user's password has been like compromised, because of that they are able to. So now change password for the user. So that is eradication, right? And then you will recover it, restore it. Like you will be like doing you will deploy the OS image again, and you will make sure that uh, there are no traces of attack happen. So that is recovery. So all this need to be done to before like closing this incident, and then you will do a post incident analysis. You will know like what is the root cause of it and what should be the process improvement. If a password is leaked due to like social engineering, then we need to give user a training. So we will come to that conclusion, we will document it, and so that the next time we will be able to prevent the recurrence of those incidents. So this is incident response lifecycle. So some of the preparation phase, like whenever there is a changes in the relationship with cloud provider in a cloud world, whenever there are like changes due to the relationship with cloud provider, we are planning to terminate their service or we are planning to add more service. In those cases, we need to look at the preparation phase. We need to look for changes in the responder training. We need to look for changes that are needed for the cyber incident response, and we also need to support the CAR technologies. Some of the differences in analysis are like previously in an on-prem, everything will be owned by the organization. They can easily collect whatever logs they want, right? But when it comes to cloud, the access to that will be very much limited, right? The telemetry for detection and analysis, including the attack surface, will be very limited, right? We'll have like very limited sets of data. So based on that, we need to collect and we need to do analysis. Second is whatever tools that are applied or working very well in a traditional network environment will not work in cloud. Cloud may require a specific sets of tools, right? And the API driven nature of the cloud and ephemeral, like I have a VM, but the moment I stop the VM, all the components will be gone, right? The RAM will go. So I cannot like reconstruct the same I cannot reconstruct the same VM. I can reconstruct a similar VM, but I cannot reconstruct the same virtual machine or EC2. So that is another, a difference in cloud, right? And again, the impact of automation infrastructure as code is also very different in cloud when compared to your on-premise. So you'll get the security alert. Once you hit the security alert or events, it will be sent to the detection response team, and you will get the source from different accounts or different subscriptions. You'll collect all that, and then you'll pass it to the SIM for analysis. Right? SIM will collate all the logs, and it will be able to detect an incident, and it will be able to discover the root cause of that. So that is how the root cause can be found using SIM, and from there a manual action or an automated response can be taken. So cloud system forensics, can be talked about snapshot, which is one of the very important like forensic component, right? So forensics is very important. There is a volatile order in which you have to collect the data. Again, the challenge is we don't have physical access to the hard disks or the resources, right? So everything is available in a virtual way. We need to capture as much as data possible within that scope of our time, right? So we need to analyze the management plane, service, and other logs. And some of the key concepts are like snapshots, which is like volatile memory acquisition. We need to collect all the possible logs, and we need to preserve all those evidences, right? Everything is now available. So previously in on-prem, it will be a hard disk, right? You can just confiscate the hard disk, put it in a locker, it will be secure, right? But we don't have all those physical media available to us in cloud, right? So we need to capture them virtually and preserve it, right, properly, so that we can present it to court for admit like evidence. And we also need to look at the forensic analysis for containers and serverless, right? When we don't have a server at all, then how are we going to um, like manage those logs, right? So environments will be relying heavily on the logs that are generated by serverless functions. That will give us a clue whether that code has been executed or not, right? That includes your execution logs, access logs, application logs. It will collect all those logs, and we will identify the invocation and execution pattern, so that we will be able to reconstruct when we are like uh, analyzing those incidents. Similarly, for containers, container states will give us an insight into the activities, right, that are data and data container processes. So the container states will give those insights, and that's why it's very important to collect all the VM logs and all the logs to an external log storage, right? You should not store it within the same environment, right? It should be stored in a separate centralized environment. So that is true for VM, that is true for containers also. And this is planning phase is done, analysis phase is done. This is containment, eradication, and recovery. Containment is mitigating the attack, right? Mitigating for like disconnecting from the network, like blocking access to a user, right? That is containment. Once it is done, now you will eradicate. You need to find the root cause and remove that root cause, right? So that comes in the eradication phase. It requires you deleting the older versions of images or changing the keys for the users, right? So that is eradication. And then recovery, you can like using IAC, immutable infrastructure, you can deploy it from your backups or snapshots. So that's an example of recovery, right? You can do an auto scaling, right? You can change the user's password, right? Those are all some of the examples of recovery. And then you need to do post incident analysis. This is very very important, right? The idea is, now we have a very good team, we are able to resolve the incident, right? But the best solution will come if we can prevent the same incident from occurring in the future, right? So for that, we need to do the post incident analysis. We also call this phase as lessons learned. So we'll do a lessons learned. We will try to find out why exactly this incident happened and how we can prevent it in the long run, right? So that is very important. So now you can create a run book or playbook for new incidents, and it will be like you due to misconfigurations and all. So instead of blaming the person, so the objective here is not to blame X or Y or Z for the incident, but to identify the gaps and to try to fix the gap. So that is called just culture approach. So we need to uh, embrace that just culture approach instead of randomly assigning blame to X or Y or Z. So just culture says, yeah, like it is not who, but it is what had happened, what mistake had happened. So that is post incident analysis. Okay, with this, we are into the last domain, 12th domain, related technologies and strategies. So we discussed all about cloud and how cloud is impacting the emerging technologies and how emerging technologies are impacting cloud. We saw a small brief in, the workload protection, right? The AI, how it actually helps. So we'll get into the related technologies. The first is This is a zero trust maturity model. So one of the emerging security options currently is zero trust. We already saw a, a group doing network security, right? So where we have like different pillars like identity, devices, right? And instead of deploying once and then like doing a periodic audit, the zero trust actually recommends you to do a continuous access for every continuous access evaluation. So for every request, it will verify whether you are a valid user and then it will provide access. For every application, it will check whether you have like valid access, right? So this is the example, or this is the advantage of using zero trust. It performs a continuous access evaluation, right? And based on the continuous access, it will give you the overall zero trust maturity model, whether you are at the traditional, like you haven't even adapted any recent security solutions or advanced or current security solutions, or whether you are at the initial stage, you are at an advanced stage, or you are at the best optimal stage. So it will give you a maturity model across these pillars: identity pillar or devices pillar, application pillar, network pillar, or data pillar, right? Based on the visibility and analytics, automation and orchestration and governance, it will be able to give you a maturity model, how mature your organization with respect to zero trust. And these security domains can be mapped to the zero trust principle. If you say like organizational management, so it has to be implemented with a zero trust culture. Identity and access management, having an MFA with context based authorization is very important. Security monitoring, you have to monitor everything. You have to always assume breach. You need to detect the suspicious activities early and dynamically adjust the access. Right? The best example is your continuous access evaluation, right? Conditional access. And then network, you'll do micro segmentation, you'll do zero trust network architecture and software defined perimeter. And then do workload. Workload is where like your zero trust device and workload security, the ones we saw, right? Monitoring, data exfiltration monitoring like DLP, this will play a very important role. Application, you will have like least privilege access and authorization with separation of duties. You will have like limit user permissions to the minimum required data and functionality. For data, you will classify, protect, and monitor the data at rest, in transit, in use, and restrict the zero data access controls. So these are some ways by which you can enhance your cloud security. The last is where AI and cloud security is getting intersected. So AI as a service, right? You purchase a full SaaS solution and you're deploying it into your environment, right? The best security practices are uh, allow only the approved services, upgrade the data privacy, include AI in the data privacy policy, only allow the approved data, right? Always whitelisted, and go for tracking the prompts and the results, right? Or in many cases, you will not purchase a SaaS assets, but you will purchase only the platform. Right? You will purchase the platform, and on top of it, you will customize it for your organization needs. In those cases, you will be doing the training, so you need to secure the training data. You need to secure the applications integration, secure the environment, secure the users and the access, and defend against the adversarial attacks like injection, jailbreaking, and all. The next one is cloud as a workload host. So where you are bringing your own model and deploying it in cloud, right? So organization will develop their own AI model instead of taking the foundation model and customizing it for your own need. You will build your own cloud model, right? Your own AI model, and you will deploy it in cloud. So you need to take care of the entire SDLC here, right? So it just provides, cloud will just provide only the raw computer sources. The next one is AI enhanced security tools. For all the security tools, there will be options to uh, kind of embed AI into those security products to make them smarter and more effective, like the playbooks that we create, right? So you can leverage AI to kind of go through those playbooks so that it can automatically recommend the solution for the security risks, right? So we need to look for options where we can enhance it using the AI, where the security tools are enhanced via AI. Okay, so these are many ways in which AI is actually playing a very important role in the cloud security. All right, so with this, we have completed the CCSK V5 exam cram. I really thank you for being a patient audience till the end. And you're not done here. So once you're done with your exam cram, immediately go to Udemy and start doing this practice questions. If you go through this exam cram thoroughly and if you do the practice questions thoroughly, I am very sure you'll be clearing it in the very first attempt. So thank you so much. Please reach out to me for any queries and I'll be happy to support you in your cloud security journey. My name is Shiva and I'm signing off. Thank you.